Okay, so before even starting, I'd like to thank Save Our Seas Foundation that made this travel possible, so thank you so much, as well as the teams in La Reunion and New South Wales with who I collaborate. Right, hi everyone, I'm Paolo, finalizing in the next couple of months my PhD journey where I work for the New South Wales government. All right, let's take you. Let's start with a fact. Sharks sometimes bite people. It happens about 70 to 100 times per year, mainly from 3 species, bull, white, and tiger sharks. And these rare events boost fear and pressure governments to respond with mitigation strategies. These strategies can be non-lethal, such as, for example, onshore shark spotters or surveillance using drones. But here I'd like to focus on the fishing gears, which are designed to capture and sadly, in some contexts, kill potentially dangerous sharks. All of these gears you can see here has been criticized for their impact on marine life, sharks themselves, and bycatch. But how come beachgoers and sharks can be protected at the same time without harming either of them? So La Reunion first and New South Wales after did start to test and then adopt a new system called Smart Drumline, where SMART stands for Shark Management Alert in Real Time. And this gear is basically an improved version of traditional drumlines, with the main difference being that the SMART has a trigger line connected with a satellite buoy. When a shark takes the bait, it triggers a magnet and the buoy sends a real-time alert to the operator waiting on shore. The operator then heads out to the buoy to retrieve, implant a tag, and release the animal alive further offshore. In New South Wales, the Shark Management Program has deployed listening stations along the coastline, and when a shark passes near the buoy detects the shark and sends an alert to the Shark Smart app to inform swimmers and surfers about the potential risk. And you can understand that the amount of data we collect from the program is huge, and we can use this science-based information to inform public. However, as a relatively new technology, science behind the smart drumlines is not much, and my work was to look at the fishery part of the New South Wales government program, and I played with a data set that I wouldn't define small, 23 million data points and more than 400,000 single smart drumlines deployment. And I use this data to answer different questions. But first of all, do they really work? Are smart drumlines effectively a good alternative? So I asked La Reunion data and I built an analysis with the New South Wales data too to understand if they are effective in reducing at-vessel mortality compared to more classic fishing gears. In this plot, you got the catch per unit effort on the y-axis. Everything that is red are mortalities. Everything that is blue are capture found alive. And you can see how smart drumlines are generally more selective than nets and long lines, showing less bycatches and less mortality. Yet, there is still something going on for the mortality on smart drumlines. And as we want to reduce even more these numbers, we need to understand the main driver. But let me open a small bracket here, because in the period analyzed, we captured 6,300 animals. 6,100 were retrieved alive, and we are talking about more or less than 97%. These numbers are already underlying how smart drumlines are. However, I explored how the capture time, so how long the animal stays on the line awaiting release, influence the mortality. And it does for 6 species in particular, not only for hammerhead species that we know they are more fragile to capture induced stress, but also for the big 3 target species that are normally considered more robust. Jumping back on New South Wales data only, there is still a lot of space to play with this massive data set. It's important to understand the driver of capture and more operational questions such as what drives the probability of triggering the alert? Or do we have enough bait at the end of the day on our hooks? All of this translates into one big overall goal: refining the New South Wales program to increase the target, diminish the bycatch, and aim potentially for zero mortality. So in the next few slides, I will try to give you a brief summary of my findings and on the most interesting species. So our friends white sharks, see how the peak of capture is moving, starting from the south in April, going up the New South Wales coastline till reaching the north in October, with cold water was being the main environmental driver. Tigers patterns were a bit more difficult to read as we got a specific hotspot of captures, but were driven by high temperature and calm sea. And lastly, bycatch species of smooth hammerhead, and I believe it's the most interesting, and I would like to focus on this, because we got more smooth hammerhead on rainy days. Why? I think this is because the smooth hammerhead is a small shark compared to the big three and can be a prey. So imagine clouds, low sunlight can help mimetizing better, and it's in this moment that they are more active and then take our baits. Capture we're concentrating in the morning, probably is a combination between feeding behavior and the bait, which ends its power of attract sharks. Another part of the analysis was done to refine the operational characteristic of the program itself. For example, small animals of some species do not have enough strength to dislocate the magnet and trigger the alarm. And we need to work on solving this to limit mortalities. Plus, smart drumlines in New South Wales are deployed daily, morning to 2 hours before sunset. By modeling the bait left on the hook at the end of the day, you can see how sometimes there is none. So I suggested to implement a midday baiting protocol in the affected locations to keep our hooks active. So to wrap up, given that the program itself is well made and well planned, our results show that smart drumlines offer a strong alternative to traditional fishing gears, helping reducing bycatch, being more selective, and lastly, but probably most important, if managed efficiently, they help striking the very delicate balance between shark conservation and human safety. So, thank you very much for listening, enjoying the remaining talks, and remember to be shark smart. Thank you.
Thank you, Paolo. We have time for at least 2 questions. Any question in the back? So this first. Sorry, do we have a mic at the back? Thank you.
Thank you for that presentation. I was curious, I don't know if you mentioned this at the beginning because I was 1 minute late, but how long is it usually to respond to a ping? And how many times would you respond to a ping in a day? What if a few of the drum lines just went off and off and off? How does that work?
So in New South Wales only, because I work for La Reunion, but I just use the data. For the New South Wales program, imagine we have between 15 and 20 drum lines, smart drum lines per location. We have a rule for the contractors that they need to take maximum 30 minutes from receiving the alert and reaching the drumline buoy. If we got more alarms, one after the other, we just start from the closest buoy and we go one after the other one.
Okay, and then also, what if you get a ping at night, in the middle of the night? Do you guys still go out?
We don't deploy smart drumlines during the night.
Okay.
Because we want to coincide the water users by surfers and swimmers with the smart drumlines deployment.
Gotcha. Thank you so much.
Thank you.
Okay, maybe one last short question. Any more? That lady over there.
Thank you very much. I have just one quick question. You mentioned the survival rates or the mortality depending on how long the shark is hooked. And you also mentioned the hammerheads. Do you have any indication what compared to the other species the survival rates are? And not just the ones you release alive, but really the survival rates afterwards. Is there any data?
So, sorry, after being released?
Yes.
Yes.
For the hammerheads.
Yeah. So for the smooth hammerhead in particular, because it's one of the most abundant bycatch in New South Wales, we deployed PSAT on them, so we can actually satellite tag, so we can see that they actually survive after.
How long?
Okay, I'm so sorry.
Till the end of the
We
battery
do
of
need
the
to
PSAT.
continue, but please have the conversation later with
Okay,
Paolo.
okay.
Thank you so much, Paolo.
Thank you very much.
Thank you. All right, and right now I'd like to present the next speaker. I'd like to invite Carl Meyer on the stage.
Good morning, everybody. Over 70 years ago, the Pacific Oceanographic Institute conducted a longline survey spanning the North Pacific and capturing a snapshot of the pelagic shark populations of that era. Now, their data summaries were fairly basic, but nonetheless instructive, revealing, for example, the equatorial distribution of oceanic whitetip sharks in this region, a spatial pattern that persists to today, where the highest catch rates are still seen in that equatorial belt. Now, our contemporary data come from the deep-set Hawaii pelagic longline fishery targeting tunas via a very expansive Fisheries Observer data set, over 92,000 longline sets and 220 million hooks. And the similarity in spatial footprints between the historic longline survey and the modern deep-set fishery allows us to do a spatially explicit then and now comparison. And that reveals a dramatic basin-wide decline in shark catch rates. And if we look more closely by species, we can see that blue sharks, oceanic whitetip sharks, and silky sharks have all got dramatically lower catch rates across that North Pacific basin compared to the 1950s. Now, if we look at annual basin-wide catch rates, we see something very interesting. There was actually a precipitous decline during the 1950s. Is this a signature of population collapse? Well, I don't know for sure, but what I can say that is when we look at the equatorial belt in the 1950s, the hotspot of oceanic whitetip distribution, we also see the same decline as we do basin-wide, so it's not a spatially biased result. And the survey fished in the same areas of the equator in 1952 as they did in 1955. And what I would note is that even the lowest catch rates during the 1950s were at least 3 times higher than the highest annual basin-wide catch rates in our modern era. Now, if we take a closer look at the catch rates from the deep-set fishery, we can see, in fact, that after a couple of decades of flatlining, in recent years, there's been an uptick in the catch rates. But this is not an indication of population recovery. It's an indication of the fleet fishing closer to the equator. And in fact, 75% of the variability in our modern oceanic whitetip shark catch rates is explicable by fleet behavior, specifically how close to the equator that they fish. So as you can see, catch rates are a little bit tricky to interpret, but fisheries observers also document shark mortality. And the blue line indicates the number of, or the percentage of dead sharks across that 30-year period. And you can see there's basically 2 phases, a sort of a high mortality phase during the 1990s, dropping to a sort of chronic 25 to 30% mortality phase for the rest of the time series. And over the last 20 years, most of that mortality has been haulback mortality. So around about 1 in 4 oceanic whitetip sharks is dead on arrival when they haul the gear back. There's been a number of policy initiatives, most importantly the shark finning ban of 2000 that was actually implemented in 2002. That's what drove those very high mortality rates down as it created a shift from sharks as a valuable target species to a low-value bycatch species because the finning was basically prohibited. But then it stuck at this chronic level of bycatch mortality, and the subsequent initiatives did nothing to move the needle, including the most recent initiative mandating that the deep-set fisheries switched from wire leaders to monofilament, enabling sharks to bite through and escape. But as you can see, it did not change the haulback mortality rate. And if we look at actual mortality numbers, we can see that 2024 had the highest numbers of oceanic whitetip haulback mortalities since records began, because the fleet moved closer to the equator to fish, they encountered more oceanic whitetip sharks, and consequently they killed more of them. So unfortunately, that particular regulation doesn't seem to have helped. So if we consider the overall picture, we have a situation where our modern catch rates are well below historic catch rates, and they're kind of stuck. There's no indication of population recoveries, and we also have this chronic phenomenon of haulback mortality that seems to be hampering oceanic whitetip population recovery. And I submit to you that the only way that we're going to break this stalemate is to stop catching sharks in the first place. Now, of course, that's not an easy thing to do. And how can we approach it? Well, one option is to implement area closures focused on oceanic whitetip hotspots. So, for example, I used a hindcast model and determined that if we were to remove all fishing effort from the equatorial belt in this particular fishery, we would reduce oceanic whitetip shark bycatch risk by 23% at the cost of only 1% of the target catch. Now, I'm sure it would work, but these sorts of area closures are, number one, politically very heavy lifts to implement, and they can have a suite of negative impacts as well. Now, another thing that we can do is we can use technology to develop cleaner longline fisheries, specifically improving shark deterrence. And that's something that our lab is focusing on right now, optimizing shark deterrent performance through custom signal design. And here I'm showing you some recent field results where we're testing our custom signals on Galapagos sharks. And we have achieved the ability to deter hundreds of consecutive bait attempts over the course of hours with these Galapagos sharks. And we are planning to test this technology on oceanic whitetip sharks in the near future. So when we turn that signal off, that bait is taken very, very quickly indeed. So in conclusion, what I would say is that we have a problem with this chronic fisheries mortality hampering population recovery. And we need to prevent capture to prevent mortality. As long as sharks are being caught, we're going to get this chronic mortality. And there's a couple of ways that we can approach it. One is through the use of carefully targeted area closures, and the other is through advancing shark deterrent technology to make our longline fisheries cleaner and less and have less impact. So thank you very much for your attention, and I'm happy to take any questions that you may have.
Thank you so much. We have one quick question. Any question there?
Very quickly, how cheap do your things have to be to make them economically viable?
I mean, that's a good question, right? So we are not at the stage of doing that sort of analysis. We're really focusing on making the technology as good as it can be. But let me just say this. If we translate this into sort of microcircuitry and there's a scaling effect, we know that with volume, the price can be relatively low. And that's not the only consideration. So the humbug for the fisherman is another one. So even if the things are 2 cents each, if they slow the roll of the longline fishermen, it's going to be hard to get them to voluntarily adopt this kind of technology.
Thank you, Carl, for the presentation. 2 quick questions. The shift.
Sorry, we are running out of time, so please take the question with Carl after this presentation.
Okay.
Thank you so much, Carl.
Thank you.
Round of applause. All right, I'd like to invite quickly the next speaker, Ms. Liyana Khalid, for next presentation.
Right. Hello, everyone. Good morning. I'm representing the Marine Research Foundation, and I'm also a PhD candidate for University Malaya, Malaysia. So in Malaysia, the understanding of Elasmobranch bycatch is a bit complicated because we have a lack of data. And the fisheries in Malaysia are a bit complex. It involves a lot of the multiple species and with low selectivity. And most of the monitoring at sea is a bit difficult. So the most of the existing data that we have comes from landings, which are not specific and don't capture what happens at sea. So as a result, there are a few things that we don't understand, we don't know. We don't know where the bycatch, shark and red bycatch are caught, or what species are affected, and where they are when bycatch happens. So what we do know is that electronic monitoring cameras is an emerging tool, and it's promising to help fill some of these gaps. So the study site is in Sarawak. Sarawak is located in the east of Malaysia, and it is the largest state in Malaysia. And the main commercial fishing gear is trawl gear or trawl nets. And in Sarawak, there's 275 licenses of vessels contributing to at least 37% of the fish landing. So at the state level, the Wildlife Protection Ordinance incorporates CITES, meaning all the species under Appendix 1 and 2 are automatically protected. But at the federal level, fisheries, they regulate, the Fisheries Act 1985 regulates the fish activities and also the management. So in this study, the key method is the use of SharkCam. It's a self-built, low-cost electronic monitoring system to collect time and location-specific data directly from the fishing operations. So it consists of a SharkCam or camera, a rechargeable battery that is powered to a solar panel. So for the data collection, we have deployed 25 SharkCams since 2024 in 3 key fishing districts, 15 in Kuching, 5 in Cebu, and 5 in Miri. So each month we will visit ports, the landing ports, and collect all the data and maintain the cameras. And when we get back to the office, we will filter all the raw images, and we will only retain images with catch. So to give you an overview, this camera takes images every 5 seconds. So in a day, we could get until 50,000 images. So what we do next is we will species the ID. For now, it will be manually. And we will also take the data of the time, date, and also the GPS coordinates. So we will ID the species until the lowest possible level, until genus or species level. So up to today, we have processed at least 60% of the images. And then once we have all the data, we will use this data for spatial analysis and to map the bycatch hotspots. So the results I'll share today are based on a 1-year data from March 2024 to March 2025 with over 2,325 bycatch incidences. So these bycatch are grouped into 5 categories, with race dominated at least 67.2%, followed by sharks, 31.6%, wedgefish and guitarfish, 0.7%, and dolphin sea turtles consist of at least 0.5%. And what's interesting about this is that 52% of this bycatch comprises of species under the critical endangered, and vulnerable. So these are some of the species that has been identified to the lowest possible level, either genus also or species. And for sharks, the top 3 species will be bamboo shark, reclaim shark, and also hammerhead shark. And these are forays. The top 3 will be Indonesian sharp-nosed ray, mahogany mask ray, and also the whip rays. So as you can see here, some of the images are quite challenging to ID. In some cases, we kind of like, we're really confident in IDing the species, but if you see on the top left corner, some of the species has other catches on top, so it is a bit difficult to kind of ID it. But if you see any misidentification, you can reach out to me and we could actually refine the results even more. So these are some of the wedgefish guitarfish. We have ID'd bullmouth guitarfish and wrinkle butters. But you can also see here that on the top left corner, again, there's also an olive ridley caught in one of the trawl nets. So other than species identification, we also examine the spatial distribution of the bycatch. Here you can see the distribution of shark across the study area. And on the left map, the color represents the catches from trawlers registered to the different district. And then Cebu is in orange, Miri with blue, and Kuching in green. And on the right side is the shark bycatch hotspots. So the main concentration for shark bycatch happens to be near Broad Island in Daro Muka. So other than that, forays, again, on the left side are the distribution of forays, and the hotspots are just off Kuching. We don't really have a lot of bycatch for wedgefish and guitarfish, so there are no hotspots. But you can see that some of the recorded were mostly around Kuching area. We also looked at some of the species-specific species. In this case is for sharks. We have ID'd 64 spheroidal species in just 1 year. And again, we looked at the hotspots is around Kuching and also Miri, slightly Miri. And for rays, the whip rays, we have identified at least 31 species, again, around the Kuching and also Miri area. But while these are all preliminary results, I think with more refined analysis, we could actually identify some of the priority conservation areas and then focus more on targeted management strategies. So overall, 52% of the bycatch species were threatened species, but these animals are still being caught in fisheries. However, this data generated could be used for relevant agencies such as the Department of Fisheries to kind of more focus management efforts on some of the key areas. And as you all know, it's not easy to ID these species, and I think from the conference we would, we're learning a lot more on the IDing of species, and we will continue to deploy the shark cameras in some of the other key fishing areas. We will be conducting Sarawak Fisheries Sustainability Forums with officials and government agency to discuss on the bycatch management strategies. And with that, I would like to thank my mentors, Dr. Nick Pilcher and Dr. Amy Then, my very hardworking MRF team members, the interns and volunteers who have helped us with the ID species, the fisheries officers, and especially our Sarawak fishing communities. So I would like to thank the past and present donors And yes, thank you from me.
Thank you so much, Liyana, for the great work. Unfortunately, we do not have time for a question. And so please approach Liyana if you have any questions of the presentation. And so now I'd like to invite the next speaker, Nina Faure-Beaulieu, for her presentation.
All right, good morning, everyone. My name's Nina Faure-Beaulieu, and I'm a PhD student at Nelson Mandela University in South Africa. And today I want to talk to you about the Marine Stewardship Council Blue Label. Now, this Blue Label is the most widely recognized seafood eco-label in the world, and it comes with a promise that when a fishery is certified with this label, it's fully sustainable. So today I want to show you that this promise doesn't necessarily hold true for sharks and rays, and provide some recommendations forward. So why is this relevant? The MSC, thank you. The MSC certifies roughly 20% of the global marine catch, and why a fishery would want to get certified is that it's very good for business and can add anywhere from 10 to 30% added value to a product sold with the blue label. So seeing that it's so good for business, how does a fishery get this label and get certified? It's a voluntary process. They're going to approach the MSC, auditors are going to come in, and then they're going to assess the fishery according to three main principles. The first is that the target stock needs to be sustainably fished. The second is that the ecosystem as a whole has to be maintained. And the third is that the fishery must generally be well managed. So where do sharks and rays come in? They often fall under principle 2 because they're bycatch. And we've heard at length throughout this week that in order for sharks and rays to be fished sustainably, we need to have good catch data, and that's often not available or at very poor taxonomic resolutions. And if we think about trawl fisheries in particular, this problem is exacerbated by very high catch rates and high level of post-release mortality. So I wanted to understand how is the MSC looking at these shark and ray catches across these fisheries around the world, especially the 75 bottom trawl fisheries. And to investigate this further, I looked at the trawl fishery in South Africa that I work with, which is the bottom trawl hake fishery. So this fishery targets Cape Hake. It's been certified since 2004, and it's benefited over the last 20 years from this certification to export 10% of the world's hake to mainly Europe and North America. Now, South Africa is also a global biodiversity hotspot for sharks and rays with about 194 different species. And this fishery is on one hand the most valuable fishery in the country, but also contributes the most to total shark and ray mortality. So how is the MSC looking at these shark and ray catches and ensuring that they're sustainable? And to illustrate this, I'm going to go through one species as an example, the soupfin shark or taupe, and go through the assessment process. So we're all going to act as MSC auditors, and we're going to assess soupfin the same way that the MSC would. And the way we do this is we ask a series of questions, and if it's a no as an answer, the species drops in level of concern, or the requirements to assess the fishery. So the first question we ask is soupfin a target? So soupfin is listed by name in the logbooks. It's the 5th most valuable shark species in the country, and it's mainly exported, I think, to Australia for fish and chips, but the trade routes are very complicated. However, because the permit conditions state that the fishery targets hake, in the eyes of the MSC, it's not a target. The next question they ask is it threatened? Now, the IUCN red listing is irrelevant to MSC criteria. They only look at CITES Appendix 1 and CMS Appendix 1 and any national legislation. So soupfin is neither of these, so in the eyes of the MSC, it's not threatened. The third question they ask is it managed? This is when it gets a little bit interesting. Soupfin does have a national stock assessment showing that it's overfished with overfishing, and there's an urgent 20-ton catch limit recommended in the fishery. However, this has not been incorporated into the permit conditions, and that's what the MSC looks at for this criteria. So again, for the MSC, it's not managed, so it drops in the level of concern. And the final question is it caught in large quantities? Now, the way the MSC determines this is that they look at the catch of the species relative to the catch of the fishery, and they have a 2% trigger for vulnerable species like sharks and rays. So in a hake fishery that catches 150,000 tons of hake, that trigger is set at 3,000 tons. To put this into context, over the last 20 years, soupfin catches have averaged at around 80 tons, and this trigger is 150 times higher than the recommended catch limit. So if soupfin was ever to meet that, there would probably be no more soupfin left in South African waters. So we've done our job as auditors. It was a no to all 4 questions. So the MSC doesn't need to assess the sustainability of the soup fin catches, and no catch limits or no management is required. I want to focus on this last question a little bit, because with the data available, it's not possible to actually answer this properly. And I'm going to illustrate this by taking you inside a trawling vessel. The nets come on board, it's emptied onto the conveyor, and the fisher sorts everything. And everything that's retained is recorded in the skipper logbooks. However, none of the discards are reported in the fishery, and this will include soup fin. Now, luckily, there's a limited observer coverage on around 4% of trips, and I tried this out for myself to understand. And this is a really powerful data set because observers are going to sample the catch at various points of the processing chain. So this data can be used to extrapolate to the total catch. And in my PhD, I estimated that for sharks alone, the shark catches were 13 times greater than reported. Now, with soup fin, there's a problem. The observer program was never designed to sample these large sharks. So they only start to appear in the observer data around 2022. So it's very difficult to kind of get a total picture of mortality. What the observer program does show is that 49 different shark and ray species are caught across the fishery, including 19 threatened species. So again, it's with everything that I've shown you today, it's hard to understand how all of these catches are being assessed as sustainable. Okay, I don't want it to just be doom and gloom. What are recommendations that we can implement to have a blue label that's working for sharks and rays? So going back to these 4 questions, what could we do to convert them from no to yes? So the first is that if a species is retained and sold and commercialized, then it should be assessed as a target. Secondly, maybe the IUCN red listing threatened status should be considered, or Appendix 2s from CITES and CMS. The scientific guidance that exists, not the government's decision about whether to implement it, should be considered, because this creates very large biases on the country in which you are in. And finally, most importantly, there should be species-relevant catch limits, not catch limits that are dependent on the total catch in the fishery. And the observer programs should be assessed on their ability to actually report on sharks and rays. And discards, especially in trawl fisheries or fisheries with very high bycatch rates, discards should be required to be reported. And electronic monitoring, as we've seen, is an extremely powerful tool, so that should maybe be encouraged or phased in throughout the certification process. And on that, if all of these are implemented in the next version of the standard, we might have a blue label that is much more meaningful for shark and ray bycatch. So today I've shown you 1 species in 1 certified fishery. As I mentioned, there's 79 fisheries certified globally, and there's a growing demand for sustainable seafood. So if the MSC is going to be the answer to this, it's a really important lever to improve the management of shark and ray bycatch across fisheries, because at the moment it is generating a lot of value and not necessarily delivering on its impacts for sharks and rays. So I'd like to finish by saying thank you very much to my supervisors and all my team, and the Observer Program, the Fishery, the department, and also to Save Our Seas for their small grant on working with the fishery for the next year and trying to improve how shark and ray bycatch is monitored. Thank you.
Thank you. Thank you so much, Nina, for the excellent presentation. We have 1 question. We have time for 1 question. Any question from the audience?
Sorry, thank you so much. You speak out of my heart, really, with this. Just 1 quick question. Have you approached or have they approached you, MSC, and discussed that with them? Because I'd be interested in hearing the response. Thank you.
Yeah, thank you for your question. At the moment, I'm mostly working with the fishery. I think because they've just been recertified, that window has kind of passed. But I imagine in the next certification, which will be in 4 years, that we'll be having conversations.
Thank you. I'll approach you.
Thank you.
Thank you so much, Nina. I'd like to invite Martina Ciprian to the stage. Let's give her a warm up applause.
Hello, everyone. I'm gonna bring you from the amazing Colombo to the Mediterranean Sea, specifically in Greece. Our work is focused on three study areas. Two of those have been identified as ISRA and one as an area of interest. Specifically, Ambraki Coast Gulf is delineated as an important reproductive area, and the Thracian Sea is as well an important reproductive area, but it's also been identified as important because of the presence of range-restricted species. And these are the species that are present in the ISRA fact sheets, specifically those that are big ones. But the biodiversity includes also the smaller species that are just because of visualization. You can see that the majority of the species we're working with are either vulnerable, endangered, or critically endangered. And our work actually started before the delineation of the ISRAs. And we wanted to understand, first of all, the biodiversity of sharks and rays in these areas, and the level of interaction with the different fishing activities. So from 2022, we focused on monitoring fishing activities in landing site, but also with onboard surveys of large-scale, small-scale fishing vessels. Actually, you're going to see that all the data is skewed towards the small-scale fishing vessels with over 1,000 fishing trips monitored with a tramelnet, because this is the gear that is mainly used in the Greek fishery. So regarding the bycatch rates, this is data that are basically only for the tramelnets. We had an interaction with 4,139 individuals, and you can see that the different bar plots have different colors depending on the area. And the first group, you can see that in the Thracian Sea, which is one of the two ISRAs, we have the highest bycatch of individuals that has been measured with number of Elasmobranchs by 1 kilometer of net. But if we consider the species group depending on the IUCN category, we have different results based on the area. So in Ambraki Coast Gulf, the other ISRA, we have the majority of the interaction with critically endangered species, while for the Thracian Sea, the majority of the interactions are with endangered species. So as a next step, because of the high level of interactions, what we wanted to do was to assess release as a possible management strategy. So the first step was to evaluate the at-vessel mortality. So you see here 4 graphs, divided depending on the gear type. On the top of the row of the bar, there are the total number of individuals assessed, and within the bars, you can see the percentage of mortality. Actually, it's generally very low for the tramelnets, which again is the mainly used type of gear. And if we consider the Mustelus mustelus, which is the 4th species in the first graph, you can see that the mortality in tramelnets is equal to 5.1%. But if we go to the gillnets, the mortality is increasing exponentially to 82.9%. Something similar can be seen with Emiliobatis aquila, that has a 13.3% mortality in tramelnets. This mortality increases to 50% in gillnets and to 80% in longlines. So different species, as expected, have different mortality rates, and the gear is also influencing this. So the next step, given the general low mortality rates at vessel, was to understand, okay, what's happening with the species if we release them. So we assessed a total of 393 individuals with, let's say that we gave health scores based on the movement of the animal and the level of injury, so it was a visual assessment. And during the short-term post-release mortality assessment, we also capsized the animal, meaning that we were putting it with the belly up, and we were counting the seconds that it was taking to turn back to the normal position. So the graph here is specifically focused on the spiny butterfly ray. We assessed a total of 72 individuals. And you can see here that there is a general trend of improvement. So with the time that passes, we have more and more individuals that are assessed in good condition. I want also to point out that the mean time of air exposure is basically 1 hour. We saw yesterday with the mobulas that there were 3 minutes, that there were the critical time for the spiny butterfly ray. Actually, fishers would have enough time to release back the animal to the sea. Again, it's a short-term evaluation, so we wanted to check what was happening in the long term. That's why we are carrying on a conventional tagging program. We tagged 554 individuals up to now. You can see that there are different recapture rates, and depending on the species, with Mustelus having a pretty high recapture rate. This is also due to the enclosed Ambrachicos gulf. It's like a gulf, so we were expecting a higher recapture rate. And also for Ayaradula, there's pretty high recapture rate, considering it's a conventional tagging program, and for Torpedo, a 4.2%. To increase the probability of recapture, we also put some posters in all the ports we have been working so that fishers could be more involved in tag retrieval. So we've seen throughout the conference the importance of engaging fishers, and also Rafid today reminded it to us. I would say that we are pretty embedded in the local community. I'm actually moved to Ambrachicos, and I'm there all year round. And in order to increase their participation in the program, we've been doing some workshops focused on biology, ecology of the species, species identification, legislation, and good handling and release. And we've been using real-size models of sharks and rays to teach them how to better release them in water without damaging. And we've carried out more than 50 workshops, and a total of 328 fishers were informed. And now we are at the step that we are receiving videos of them releasing animals with the practices that we've been teaching them. And that's it. I wanted to thank all the fishers of Ambrachicos, Lemnos, and Kavala, all the interns that have been working in the data collection, all my colleagues, and all the funders, Shark Foundation, Ocean Cat, Save Our Seas, Blue Marine, and the LSP program. And thank you also to the BRT team for putting together this amazing conference. And yeah.
Thank you, Martina. We have time for one question. No question? I have a question, if you don't mind.
Go.
So there is, no, sorry, I have one question, if you don't mind. There was this scale, I'm not sure which slide. What was it called? Moribund, what does it mean, the status of the species?
Yeah, so basically, based on literature, there are 3 stages in which the animal is considered alive. The good one, when it's having like good movement and it's not stressed, no injuries. The second is fairly good, so it's doing well, but it's a bit stressed, so it has minor injuries. With the moribund is when basically it's just moving the spiracles, so you can tell it's alive, but it has basically no reaction. So for instance, also when we flip in it with the belly up, it just sunk down and is having no reaction. So it's basically almost dead, or in the future days, it's probably gonna die.
Thank you so much.
Thank you.
All right. Thank you, Martina. All right. I'd like to invite the last speaker for the session before morning tea. Let's invite Mr. Irul. Let's give him the warm applause.
Okay. Good morning, everyone. My name is Hairul Hadi or Irol. I am a bycatch specialist for WWF Indonesia, and I'm very happy to be here because this is my first Shark International. And today I will be presenting our study regarding community-based monitoring of fisheries bycatch in the Derawan Island APA for shark bycatch mitigation. Yeah, this is the Derawan Island. Derawan Island is located in East Kalimantan and one of the marine protected area in Indonesia, and covering more than 200,000 hectares. The Derawan Island is also part of the Coral Triangle and is home to more than 800 species, including reef shark, reef fish, and ETP species. While Derawan Island is renowned for the sea turtle, shark and ray population in this area are also highly abundant. More than 100 whale shark, more than 50 fish, and also the BRAF assessment in this area recorded several shark species with the value 0.5 individu per hour. Shark population in this area are treated by various factors, with one of the major threat being a bycatch from fishing activities. From a bycatch assessment previously, more than 750 sharks are estimated to become bycatch annually. And from over 1,000 active vessels using various fishing gear. Considering high bycatch potential, we tried to gather more comprehensive information. And the initial idea was to conduct community-based bycatch monitoring. And this has four main objectives. Number one is engage fishers through local champion to promote ownership and long-term participation. The second one is collect fishers and bycatch data to inform evidence-based management. And the next objective is improve understanding of shark and other ATP species bycatch to support mitigation strategies. And the last, focus monitoring effort on priority location within the Derawan Island MPA. The activity is divided into three main components: data collection, verification, and analysis. For data collection, the local champion focus on collecting fisheries activity data and bycatch information from at least 10% of all fishing trips, including fishing gear, catch composition, bycatch information, and bycatch species photo evidence. And for verification, we verified the data from the local champion that collected before. And the last one is data analyze. This is to summarize bycatch information from all of the data. We were focusing on three priority location and priority fishing gear, including handline, longline, and gillnet. And with the focus is shark bycatch and also other ETP species. And during the implementation of the activity, we faced several challenges. Number one is bycatch is often underreported due to low awareness of fear of regulation. And number two is photo evidence is sometimes of low quality, limiting accurate identification and verification. Number three is fishes participation can be inconsistent due to time constraint, workload or fluctuating interest. And number four, limited capacity in data recording and species identification among fisheries. And from 3 years of data collection, we recorded a total of 2,293 fishing trips across three fishing gear types, with an average of 764 trips per year. And this table presents the annual number of collected trips. In 2023, A total of 757 trips were collected, but the number decreased to 664 trips in 2024. This is because some fishers became less willing and report their catch. In 2025, the number of trips increased again to 872 trips, or increased 31%. Over the last 3 years, average trip coverage received 5-10%. Despite annual fluctuation in trip number, local champion still cover last 10% of total trips. And the percentage is calculated based on recorded trips relative to total expected trips. And during 3 years of monitoring, and despite multiple challenges, we documented 180 individual shark as bycatch. Unfortunately, only 48 bycatch individual were identified to species level, and this is the BPUA for each year, bycatch per unit effort. And based on annual bycatch number, we estimate the total bycatch as shown on the table in the blue color. And this is the result of shark data collection over 3 years, handling, fishing gear, and hake presented by incident among the other gears, with the value is 17%. And this is the important note for us. And the table summarizes the number of sharks that were successfully released alive after bycatch incident. But unfortunately, the shark bycatch in gillnet were not able to release because they were already due to the entangled. And you can see the picture. The blue gear grid is fishing ground across the Derawan MPA. Fishing activities occurs across multiple MPA zones, including area outside the MPA. And the distribution highlight fishers dependent of resorts within the MPA. And fishing area extend from coastal water to surrounding zones outside the conservation zone. And the spatial pattern reflect traditional fishing area used local fishers. And this slide explains the overlap between fishing ground, bycatch, and MPA zoning area. When looking at the location, many fishing activities are found within MPA and ISRA area. And most of shark bycatch in MPA zone, this can be seen in the red and orange grid. And bycatch incidents are also recorded outside the zonation area with similar high number. And this condition is significant challenge, especially regarding with the MPA areas. And this is an important lesson learned and takeaway from our activity. We need a strengthen the fishers voluntary reporting system with the reporting gaps remain, expand local champion, and consider incentive to improve reporting consistency. And then focusing mitigation effort in low moderate bycatch area with the prioritized mitigation in low moderate bycatch area, expand safe handling and release training, and increase distribution release training. And the last is strengthening the MPA management capacity with the strengthened MPA, especially in the core zone, improve surveillance and compliance, and strengthening coordination with the local stakeholder. And we would like to express our appreciation to this to local champion and their dedicated and successful involuntary collecting fisheries data from local champion. Thank you.
Thank you. Thank you, Mr. Iro. If you have questions, please find the speaker. We're now going to have a morning tea session. All right, let's give a one of applause.
Good morning. My name is Emily, and I am a PhD student at Charles Darwin University in Northern Australia. And I'm looking at assessing bycatch deterrent devices to reduce elasmobranch deterrence in Northern Australian gillnet fisheries. It's no surprise to anyone in this room that sharks and rays are threatened globally, with fishing being a main driver. Deterrent devices have been used to reduce the catch of threatened elasmobranchs and other species in commercial fisheries. Lights designed to illuminate fishing gear have shown promise in reducing sea turtles, seabirds, and cetacean catch rates in Peruvian gillnet fisheries and elasmobranchs in Mexican gillnet fisheries. There have been mixed results in reducing the catch rates of elasmobranchs in Mexican gillnet fisheries and captured benthic elasmobranchs. Pulsed electric devices designed to overwhelm the ampullae of Lorenzini have shown success in captured sandbar sharks, sand tiger sharks, and sawfish, as well as field trials involving the pelagic stingray and blue shark, as well as depredation studies on captured bonnethead sharks. There have been mixed results with personal shark deterrence, and captured benthic elasmobranchs have shown no deterrence to pulse devices. So Australian waters have been described as a lifeboat for over 45 globally threatened elasmobranchs, in which species may not face intense local threats, however they are under increasing pressures elsewhere within their geographical range. Australian commercial fisheries are generally well managed, with strong regulations, monitoring and stock assessments to support sustainable harvest. Fishers play a key role in sustainable fisheries, actively complying with regulations, adapting practices, and contributing to data collection and monitoring processes. However, one type of fishing pressure in Northern Australia is the gillnet. Gillnets, or pelagic nets, consist of a sheet of thin monofilament framed by a rope with floats and a weighted lead line, and is held in the water column using floats. It is considered a passive method, where animals swim through the net and get stuck on spines, teeth, fins, and other morphological traits. In order to reduce the interactions of elasmobranch bycatch in Australian commercial net fisheries, we aim to test off-the-shelf bycatch deterrent devices. This will help implement uptake if proven successful. We aim to test these devices for target and bycatch species, specifically looking at elasmobranchs. We did this using a multi-fishery approach in Northern Australia, working within the Northern Territory offshore net and line fishery and the Gulf of Carpentaria inshore finfish fishery. Both fisheries target mackerel and blacktip sharks, while also retaining whalers and other finfish as byproducts. Common discards in both fisheries include milk, sharp-nosed and hard-nosed sharks, and eagle rays. Species of conservation concerns include hammerhead sharks, which are considered no-take in the Gulf of Carpentaria and are quota managed in the Northern Territory. Our threatened species, which are not able to be retained under any circumstances, include 4 species of sawfish, a variety of devil and manta rays, as well as marine mammals and turtles. We worked with the industry to shortlist the devices used based on their effectiveness in other fisheries and just due to being of interest to the fishers. We used the FishTech Marine Net Light, which is a static green LED light, and the FishTech Marine Shark Guard, which is a pulsed electric deterrent initially designed for longline fisheries. Due to slight operational differences of the two fisheries, the study was varied based on the operational context. In the offshore net and line, we used a 990-metre net comprised of a variety of green twine and monofilament, whereas in the offshore net and line fishery, we used an 1,800-metre net comprised entirely of monofilament. In both fisheries, the devices were attached to the float line, with one being attached on the float and one between the floats, causing the devices to be spaced at 7.5 metres apart in the Northern Territory and 12.5 metres apart in the Gulf. The devices were attached with relative ease, however there were some entanglement issues during the haul. Fishing occurred in March and July of last year for the respective fisheries, and all fishing occurred at night time, with up to 3 shots per night. The nets were set for 2 to 4 hours, and all animals were identified to the lowest taxonomic level, with the catch per unit effort being calculated. Our aim was to look at threatened species, however, the catch rates were low, so we weren't able to conduct any statistical analyses. We did catch 1 longhorn pygmy devil ray in the electric section of the net in the offshore net and line fishery. We caught 1 narrow sawfish in both paired control sections, with an additional 2 being found in the electric section of in the Gulf of Carpentaria, as well as a sea snake in the electric section of the net. However, we were able to look at other sharks and rays. For our lights, it had no impact on the target species, so our grey mackerels and black tip sharks. There was a significant decrease in the catch of spot tail sharks in the offshore net and line fishery, and milk sharks in the Gulf of Carpentaria. There was a moderate increase in aggregated hammerhead sharks, with all great hammerheads being found exclusively in the light section of the net in the Gulf of Carpentaria. However, this sample size was low, so further trials are needed. For our electric devices, again, there was no impact on the target species. There was a significant increase in the spot tail sharks in the offshore net and line that was not seen in the Gulf of Carpentaria, and a moderate decrease of aggregated hammerheads in the offshore net and line. So what does all of this mean? Our key findings show that there was no impact on target catch, with mixed trends for elasmobranchs, likely due to differing sensory ecologies. There was low catch rates of threatened elasmobranchs and high variability between the sets. Due to limitations, and to explore these trends, further trials are needed, and we are actually continuing the trialling of the light device. Both devices did not show enough of a deterrent effect on bycatch to warrant industry implementation. However, it is important to note that there was variances between the fisheries and species, highlighting this context and species diversity and specificity of these devices. I would like to thank the funders and our industry partners for this project, and are there any questions?
Thank you, Emily. Wonderful presentation. We have time for 2 questions. Jack, can we have a mic there?
Hi, Emily. Nice talk. I'm curious, when you used the 2 devices, what was the spacing of the devices on the gillnet itself?
So on the gillnet in the offshore net and line, it was 7.5 metres apart from each other, and then in the Gulf of Carpentaria, it was 12.5 metres apart.
So do you think that had an impact on your potential catch rate?
Absolutely, yeah, it definitely would have had an impact. However, that was at the spacing that was of the best kind of spacing that we could do feasibly with the fishes. When they hold the net, we just put it on the float, and then between the float, we didn't have enough time to put more on.
All right, thank you. We have time for 1 more question. If anybody has a question, we have 1 more back there.
Thank you very much. Really nice talk. Do you have an explanation why it was specifically the hammerhead sharks that you had a higher, or you had an increase? I acknowledge that the sample size was very small, but is there an explanation you have for that? Or
It is probably due to their visual capabilities. Yeah, that's something that we're still looking into, but yeah.
Thank you.
Thank you.
Emily, thank you so much. We'll now move to a speed talk. I'll invite the first speaker, Gloria Mariño.
Good morning, everyone. My name is Gloria Mariño, and I will present to you the first chapter of my PhD thesis that is on catches of Elasmobranch species in ICAT. ICAT is a tuna regional fisheries organization that works in the Atlantic region. In its mandate, it promotes the sustainable fisheries of tuna and tuna-like species, and also the conservation of associated species, such as sharks and rays. What is the context of Elasmobranch catches in ICAT? Well, they are mostly caught by longliners, purseaners, and gillnets. The top shark officially reported is the blue shark, and most of the countries only report 1% of shark and ray catches. So this leaves us to two issues. The first one, there is evidence of underreporting by ICAT, and the second, there is limited access to fisheries observer data. So under this panorama of poor data and interaction between the fisheries and the sharks, we asked two questions. Where and how many pelagic elasmobranchs were caught in ICAT fisheries between 2010 and 2024? So basically what we did was to do a literature research on bycatch rates reported by observers. Then, such as blue sharks by 1,000 hooks. After we used the total effort for this fishery, and then we calculated the total catch. So right now I'm going to present preliminary results, and by now we have only results on longliners targeting tropical tunas in the Atlantic. So as you can see in this map, most of the main catches are around the African coast. Furthermore, if we zoom into the species detail of these catches, we can see that the top catches annually are for blue shark, followed by a smooth hammerhead, and the third one is unknown sharks, that you can see the gray bar at the bottom. And moreover, there are only 5 species that contribute to total 90% of the catch, and most of them are in threatened state. So we compare the official ICAT data versus our estimated data. And we found that we estimated catches for 20 taxa groups. But when we compare to ICAT data, 5 of these taxa groups were not present in the official reported data. And 3 of these species are reported, we estimated them as top cuts. The next steps are to continue working on estimating the catches for ICAT fisheries, for all of them, including purseiner gillnets. And I want you to take this key message, because we have in ICAT an absence of accessible data. So as an alternative, we can do extrapolations, which can give us an idea of the bycatch magnitude of underreported Elasmobranch species. Thank you so much to my team and to everyone that helped me to be here, and to my co-authors.
Thank you, Gloria. Wonderful presentation. We have time for questions. Any question from the floor? If there.
Sorry, me again. Thank you very much for that interesting talk. Just a question about the blue sharks. You said they are bycatch, but which fishery is this, you mean? Because I know certain fisheries call them actively a targeted species, which they are. Is there any insight you can share? Thank you.
Yes, sorry, I didn't use the word, maybe I confused, but the idea is not to talk about bycatch in this talk, is to talk about catches, because we know that in the ICAT area, blue sharks are targeted, and actually they have a stock assessment in this area.
All right, we have question, one more question. Yeah.
Thanks, Gloria. Great talk. I'm wondering just, so you took bycatch estimates or bycatch rate estimates from the literature, if I understand. Where did they come from? Like what area, and how recent or old were they?
Hola, David. Thank you for the question. Actually, it was very hard, because what we did was going through ICAT documents for every fleet that operates in the Atlantic Ocean, and they have in some of the papers information of where they got the bycatch. For example, they would say in the North Atlantic Or in Grand Banks, for example, we got these sharks by these hooks. And in the tropical areas, we got this and this. And that's how we are classifying. Actually, the results are by areas, but I didn't have time to show. But yes, in the literature, we have references of where they are getting caught. Thank you.
Thank you so much, Gloria. Wonderful. I'd like to invite now Leire Lopetegui to the stage.
So, hi everyone. My name is Leire Lopetegui-Eguren. I work at ASTI, and today I will present a work where we assess the vulnerability status and the efficacy of conservation and management measures for Atlantic Ocean silky shark. So, silky shark might be decreasing in the Atlantic Ocean. However, the population status is unknown. But as we mentioned, these are bycatch species and data poor, so conventional stock assessments are not possible for these species. So this highlights the need to use data poor methods such as ecological risk assessment that were already used using productivity susceptibility analysis. And in this analysis, we could see that silky shark were considered at risk. However, these analyses were only done for longline fisheries operating in the Atlantic Ocean, but we do know that silky shark are bycaught not only for longline, but also for poor seiners, gillnets, and handline fisheries in the Atlantic Ocean. So we needed an assessment where cumulative impact of different fisheries were considered. So in order to do that, we use the Easy Fish framework, which is ecological assessment of sustainable impacts of fisheries. And so this framework has like two main components. One of them is the susceptibility, where you basically calculate the volumetric overlap with the species distribution, with the effort, and other susceptibility parameters. And then you estimate the fishing mortality. When you estimate this fishing mortality, this is applied to a length per recruit model, and with using biological reference points, we can assess the vulnerability status. So in my case, the vulnerability status was considered increasingly vulnerable when considering uncertainty in some parameters. But as you can see, there is high uncertainty in this vulnerability status. However, we do have a reference point where we can try different mitigation and management measures, such as avoidance measures, also some minimization measures, such as white leaders and J-hook ban, also remediation measures, such as best handling and release practices and bycatch release devices, and a combination of different measures. So with these reference points, we estimated the effectiveness of different measures, and here we can see that avoidance measures have great impact considering like moving the species to least vulnerable. For minimization measures, the effectiveness is less. Also, for best handling and releasing techniques or remediation measures. And finally, when combining different mitigation measures, we can get also greater effectiveness. So in a nutshell, this is the first time the silky shark vulnerability status were estimated for the Atlantic Ocean. However, we identified data gaps and uncertainties in some parameters, and we are working on that with the stakeholders and different ICAT fleets in order to improve our assessment. So I would like to thank all the co-authors, also the funding entities, and I don't know if there is time for any question. If not, you can reach me or just email me. Thank you.
Thank you. There is time for questions, so we'll take one question. Any question from the floor? Oh, here you go.
Thank you very much. Really interesting insight. Are you considering doing that also for other sharks?
Yeah, so one thing that we want to avoid is the piecemeal bycatch. So we are also going to work on hammerheads and mobulids. But the idea is to try to gather more information and to apply it to different species, yeah.
One more question? Quick one.
Hi, Leire. It's me and Iris that are just going to do tag team for this session. So your avoidance measures had a big impact. Was that avoidance, did that take into account sort of effort redistribution, or how did that work? And could that change maybe your assessment of the value of avoidance measures?
Yeah, so we know that the avoidance we try are not really realistic right now because we were using static avoidance, so and no reallocation of effort. But yeah, it was a simple approach just to try different scenarios. We were also trying like huge number of days closures. We know right now they are not realistic, but yeah, they are there, so. Thank you.
Thank you so much, Leire. I'd like to invite the next speaker, Paolo Gabasa.
Hello, everyone. Thanks, Irina, for the introduction. Again, my name is Paola Gabasa. I come from the University of Valencia in Spain. And today I'll present some insights from one of the chapters of my PhD, which addresses the spatiotemporal drivers of pelagic shark bycatch in the Atlantic Ocean. This work is part of the REDUCE project. This is a project that aims to better assess and reduce marine megafauna bycatch in the European long-distance fleets operating in the East Central Atlantic. As you know, drift and longline bycatch remains a major challenge for sustainable fisheries, and especially for pelagic sharks. Sorry, thank you. Yeah, okay. So to address this, we use CPUE data or catch per unit effort data from the Spanish Onboard Observer program, collected between 2018 and 2023, and covering nearly 3,000 fishing sets, here shown in pink within the study area. And we focus on the 3 species with the most robust or comprehensive data sets, and that is the blue shark, surfin mako, and big-eye thresher. Our goal is simple, to understand where, when, and why sharks are caught. So how do we approach this problem? Well, for each species, we fitted machine learning models, specifically Bayesian additive regression trees, or BARTs, combined with the delta or hurdle approach. Basically, this means that you used a 2-step modeling approach. So first, we model occurrence or bycatch risk, estimating the probability of presence or a bycatch event. And then we model CPUE conditional on presence. And finally, both components are combined to estimate expected CPUE. And importantly, we included a random intercept at the trip level to account for differences in fishing behavior. So what did we find? Well, this is still a work in progress, but our preliminary results suggest that in general, occurrence is reasonably well predicted, but CPUE is much harder to predict. Here I show the delta model predictions for the 3 species on a given day. And we observe some differences across species. So blue shark behaves as a generalist and seems to be strongly driven by fishing behavior, likely because it is also a target catch for much of the fleet. Surfin mako shows a clearer oceanographic signal, particularly linked to thermal structure. And finally, big-eye thresher appears to be more related to light-driven and vertical processes. However, model performance, especially for CPUE, remains low, and we observe high variability across fishing trips. So this suggests that a large part of the variability is not explained by environmental conditions alone, but by factors such as fishing behavior and at trip level effects. These results highlight the limitations on relying only on environmental data to predict bycatch, and especially for species that are strongly influenced by fishing strategies. So we believe that incorporating both environmental variables and fishing behavior is key to improving bycatch predictions. So what's next? Well, as I said, this is still a work in progress, but building on these results, the next step is to further improve the models and incorporate additional operational variables. And then we aim to link model outputs with fishing effort data to move from relative indices to absolute bycatch estimates by species. And with that, I'd like to thank you for your attention, and special thanks to the BRT team for doing such an amazing job organizing this conference. And I don't know if we have time now, but please feel free to reach out if you have any questions or comments.
Thank you, Paolo. We don't have time for questions, so please approach Paolo after this session if you have a question. Now I'd like to invite Chloe Blandino for the next talk.
I analyzed Hawaii pelagic longline data to identify key predictors of silky shark bycatch. The deep longline sector, targets big-eyed tuna, and the shallow sector focuses on swordfish. There's distinct CPUE hotspots relative to fishing effort that largely overlap the southern distributions of silky sharks. Bycatch was strongly spatially structured with significant equatorial skew, where most of it occurs between 9 degrees north and the equator, mostly overlapped by the deep longline sector. I first looked at how spatial dynamics influenced distributions. Bathymetry and latitude and longitude were significant predictors of silky shark occurrence, which is highly localized at depth, with overall high abundances on deep lines. There was a strong seasonal habitat shift where they extended their ranges into higher latitudes during the summer before dropping back down to lower latitudes during the winter. And this habitat shift affected seasonal catch rates. So during the winter months, silky shark CPUE increased. I also examined changes in CPUE and post-capture outcomes and whether management policies affected mortality proportions. So in 2004, fishers were no longer allowed to take or fin sharks, and wire leaders were phased to monofilament in 2022. Bycatch significantly decreased over the last 30 years. After 2004, catch rates declined by nearly 60% despite the total fishing effort increasing. And the total proportion of dead silky sharks decreased, implying that the finning ban and non-retention significantly improved overall survivorship. After 2022, CPUE increased despite total fishing effort decreasing, but as wire leaders were phased to monofilament, we should have theoretically observed a decrease in shark CPUE because of shark bite-offs. Thus, an increase in it might be interpreted as population recovery. I then asked if the seasonal movements and changes in habitat or changes in catch rates were actually being driven by sharks themselves, or if seasonal fleet movements were driving this signal and influencing distributions. So I tested if silky shark encounter risk matched the observed seasonal habitat shift independent of seasonal fleet movements. I weighed effort versus risk latitude centroids, where absolute shark risk is given by the red line in that upper graph, and fleet effort is given by the blue dashed line. And as you can see, as fleet effort shifted north, shark risk stayed almost perfectly stable during both winter and summer and consistently concentrated at lower latitudes. CPUE declined earlier on in the time series and remained stable after the fishing area was held constant, meaning that CPUE declined as the fishing effort moved away from historically higher risk areas. Catch rates strongly depend on where the fleet is fishing, but CPUE isn't simply following fleet movement, so there is real spatial structure in shark encounters. The core punchline here is that catch rate variability will arise when there's overlap between fishing effort and a pretty stationary silky shark footprint as opposed to true latitudinal migration. And that matters because depending largely on fisheries-dependent CPUE data can vastly misrepresent what is happening ecologically. For now, we know that Hawaii bycatch occurs highest closest to the equator, encounter risk is seasonally stable, and catch rates will change as the fleet fishes in different areas across the risk landscape. Hawaii silky shark bycatch is strongly spatially structured and highly sensitive to underlying factors such as fleet scale behavior and gear selectivity. So disentangling bycatch drivers is critically necessary for directing effective mitigation of it. Thank you.
Thank you so much. We don't have time for questions. Please approach the speaker if you have questions. I'd like to invite the next speaker, Shonat, to the stage.
Yeah, it's for confidence. Yeah, I got some confidence. Yeah, hi everyone, good afternoon. Hope you are enjoying Sharks International 2026. Yeah, I'm Shaunat Situation, a researcher from Blue Resources Trust. So today I'm going to show how the machine learning can help us to understand the mobility population trend in Sri Lanka. So the main problem is mobility vulnerable. So in Sri Lanka, mobility bycatch in gillnet fisheries. So and also the gill plate export is now fully banned, but people are still retain it and they are hiding it. We won't let them continue. So, but we need strong evidence for that. Yep. So, according to our data, we surveyed around 134 landing sites. Also, from 2011 to 2025, across species like Mobila tarapacana, Mobila thurstoni, and Mobila byrostri. So you can see the pie chart. So across 60% of landing site, we very rarely surveyed, and 7% of landing site, we are like frequently surveyed. So why? Because we don't have enough staff and we don't have enough resources to cover all over the Sri Lanka. But that's why I came with the model. So this model making predict the daily data from 2011 to 2025. I used random forest classifier for this. So if you need any technical related discussion, you can scan the QR code. So this is my key findings. So you can see the Negombo Fishery Harbour, Midisa Fishery Harbour, and Faure-Beaulieu Fishery Harbour under risk. And also during the southwest monsoon is like 5 individual catch per day they are getting. Also all 4 species I mentioned get declined all over from 2011 to 2025. So my takeaway message, this model identify when and where the priority and risk management needed. Also, now I have a daily data for all the landing sites. So I have a roadmap for the where we need to survey. Also, this framework can scalable across different Sri Lankan coastline. Also, it can be replicable for all other Elasmobranch species. Thank you for listening to my slower speed talk. Thanks for the BRT team and all came for the Shark International.
Thank you, Shona. Excellent timing. We have time for 2 questions. Any question from the floor?
No. Hi, great talk, great concept. I was wondering if you had any opportunity to ground truth your model predictions by checking other landing sites and see if your model is predicting actually what.
Yeah, actually, I validated and I got a results AUC 0.7. It's a like median average results. But also I got particularly our most frequent landing site is Valachene. We got more landing in Valachene of Mobila, but after the model, Negombo actually it's predicted Negombo Harbour having the more landing site thing. So actually it's happening. So yeah, I'm thinking it's did very good job. Yeah.
All right. Any other question? or else we'll move to the next speaker. Thank you so much, Shonat.
Thank you.
Excellent. All right, now I'd like to invite the next speaker to the stage, Guillaume Teguila.
Hello everyone. I am Guillaume Rode and I work with Tubeao in Cameroon, and I live in the local community where I often saw sharks and whales being caught. This made me ask a simple question: how a discussion happening? That question led me to this investigation. Cameroon coastline is a key habitat for marine biodiversity, among them sharks and whales. Unfortunately, they are increasingly impacted by fishing practices. Bycatch represents the major but poorly documented trait. This lack of scientific data limits the implementation of effective conservation measures. To better understand this issue, we conducted a study in and around the Marine National Park, Manyangena Ilombo Campo. The methodology combined a field survey using a questionnaire on cover collect with a training of 4 fishermen to use the Siren apps to recall GPS coordinates when and where catch is happening. A total of 86 fishermen were interviewed, and the results show that 94.2% of fishermen are Cameroonians and others Nigerians. Fishing is the main activity for all respondents, with the most operating 6 days a week. 81.4% of fishermen don't intentionally target sharks and whales, but the main gears involved in bycatch were bottle gill nets. And the other side, 18.6% of fishermen intentionally target sharks and whales, and mainly are Nigerians, and they often use a small mesh net that increase the bycatch of sharks and whales. Concerning the species identified, of the 26 shark species, 19 are classified as threatened by IUCN, and 24 rare species, at least 18 are IUCN threatened. Concerning the key zone identified, 2 areas emerge: a northern zone within and around the Marine National Park, and the southern zone extending Equatorial Guinea. Despite the reluctance of some fishermen to participate due to concern about data use, one day after a session of environmental education with the children, they called me, "Rod, come, we want to know more about sharks and whales." And I was like, because during my field survey, they told me that, no, we don't want to answer your question. And this is why I'm going to continue to raise awareness by also the support of Padi Foundation again, to raise awareness and environmental education. This is not just to communicate with them, but also to build a strong collaboration for our future project, to collect data on the landscape, to train them how to release sharks and whales. I will not close my end to say thank you to my team, to Padi Foundation who fund this project, and to Blue Resources Trust and Shark as well, who enabled me to attend this conference. Thank you to you too for your kind attention.
Thank you so much. We have time for one question. Any questions from the floor? No? No question? Okay. Well, thank you so much for the presentation.
Thank you.
All right. I would like to invite the last speaker for this session. Let's give them a round of applause to Charlotte Knight.
Yes, so hello everyone, I'm Charlotte. I'm based at ETU in Ireland, and my PhD is looking at how to optimize environmental DNA technique to monitor the bycatch of Elasmobranch in the Northeast Atlantic. So in this Beyond the Net session, we have seen that the bycatch estimates and its impact on Elasmobranch are likely underestimated. And to monitor the sustainability of populations, invasive traditional survey methods like bottom-trolling are usually used. So we need non-invasive and precise technique to monitor better the bycatch of these threatened species, and eDNA holds great potential to reach this goal. We want to develop a bycatch monitoring technique optimized for different types of fishing gear by sampling the water at different stages of the fishing process. To facilitate its application in fisheries, we need the sampling to be fast and easy. We just use passive sampling devices like the Metaprobe from Meyer or similar alternatives. And then we used eDNA metabarcoding using ELASO2 and the RIAS primers. So we first sampled 4 holes on a bottom trawl in Irish waters. 1 metaprobe was placed in the nets, and 1 metaprobe was in the hopper where the catch is landed on the boat. First question, can eDNA detect everything that has been bycaught? And yes, it can. The holes are combined here, and in the middle here in purple, you see all the species that have been detected by eDNA, but were also caught in the nets. And on the right are the species that were caught in the net, but that eDNA has not recovered. But these exceptions, they are likely due to discrepancies in the reference databases, because, for example, Dipterus intermedius and Dipterus batis, they have long been considered wrongly as the same species. And then can we go even further and correlate the eDNA read counts with the catch biomass? There is a positive relationship between biomass and eDNA reads, meaning that with higher biomass, we will generally see a higher amount of eDNA sequences, like DNA calcea on the right. However, there are some outliers showing a high variability in the eDNA signal. For example, Griseus, with 12 kilos, we obtained 4,000 reads, but for the cuckoo ray on the left, with only 500 grams, we had 96,000 reads. Now, we try as well to monitor the bycatch on a gillnet boat, and we sampled 6 holes in a fjord in Iceland. We had 4 sampling types, 1 metaprobe at sea, 1 metaprobe on the other side of the boat next to the gillnet being hauled back. Then a pipe was collecting the water dripping from the nets, and finally the sorting boat after the fishing process. Again, same question, what do we detect? On board, only the thorny skate and the harbor porpoise were recorded in the bycatch data, and eDNA detected it, but way more species as well, like for example, Chimera monstrosa in the pipe and the sorting board, or the Greenland shark on the sorting board samples. And so eDNA can detect what has been bycaught, but how to translate the eDNA reads into true bycatch detection, because species might have been released or predated on the nets, and also siphoning out detections from the surrounding water. So now the real investigation starts, and we'll see what this PhD will provide. And if you have the same challenges or opportunities of sampling, please come chat with me, and thank you very much for listening.
Thank you so much, Charlotte. We have time for question. Any questions from the floor? No?
Any questions?
All right. Thank you so much, Charlotte. Oh, okay, sure.
Hi.
Hello.
Thank you for your talk, your speed talk. So my question is just about the kind of sampling. Are you sample fin or just water?
It's just water.
Oh,
So,
okay.
I mean, the only thing that could be a bit more fish is when I'm on the sorting board, because so all the fish in the net is coming on the sorting boards, and then I actually wiped the water and leftovers from the sorting boards, so then there is a lot of tissue then. But the rest is just water at sea, water dripping from the nets, and yeah.
Okay,
so no
thank
fish.
you.
Thank you.
Great presentation. Thank you, Charlotte. All right, we are now transitioning to a next session.
Speak about the STAR Thailand project. May, take it away.
Nesha is very tall, so I have to move the mic down. So hello everyone, I'm May, I'm from Thailand. And today I would like to talk about scaling shark rewilding. So from Nesha to Thailand. So first, I'd like to give a little bit of background. So our project in Thailand started with the citizen science project, building on that foundation from Dr. Christine Dudgeon and in collaboration with Dr. Kongkiat from the Department of Marine and Coastal Resource. This started way back in 2013, where you can see Chris up there. And from this data set, it shows that there has been a noticeable decline in the leopard shark resighting over the years. And this really matched up with a lot of the anecdotal report from the divers and dive operators in Thailand. They are saying that the boring shark is kind of gone, because in Thailand, it used to be a boring shark. It's everywhere. They always dive and then they always see one. So it's like it became nicknamed as a boring shark, but nowadays it's not so boring anymore when it's gone. So that's why in Thailand right now it became like, if you're lucky, you see one shark kind of a thing. And that kind of coincide as well with the fisheries statistic from the Department of Fisheries in Thailand, where it shows like over the past 20 years, there's been a significant decline in the shark landings in Thailand, and that is quite indicative of how the population status of sharks in Thailand is. So to address this, Reshark has reached out, and also we have been able to adopt the Reshark framework into our roadmap. And I'll walk you through how we move from data collection to planning to implementations. So building on the previous effort of the citizen science program, we have WildAid and Ocean Blue Tree have joined hand in continuing the citizen science program after the pandemic. And we focus very heavily on outreach activities, trying to produce a lot of different communication materials, attending events, and continuously engage stakeholders, especially since Thailand is a very tourism-heavy country. We have a lot of citizen science with camera diving in our waters, so that helps encourage photo submissions, and these photo IDs data were then assessed into initial population, which we feeds into the population viability analysis for the STAR Project Thailand. And for STAR Project Thailand, we have our population viability analysis done after we have a lot of information from the Indonesia counterpart as well. So this gave us a very solid scientific foundation in terms of how we should do the rewilding program in Thailand. And our assessment actually analyzed that there's currently in Andaman Sea, there's around 57 to 172 individuals left in the wild, and comparing that to our carrying capacity in the Andaman Sea, it can reach up to like 1,000. So this means that it's quite vulnerable to demographic fluctuation, environmental disturbance, and also genetic loss. So this model also shows that under all release scenarios, we have benefits in terms of population recoveries and also reduction of genetic diversity loss. So after we have the PVA, now is the next question is, where should we release the shark to maximize the survival? So we chose the area based on two main factors, which is the important sharks and race area for Indo-Pacific leopard shark. This is also done based on the citizen science work done by Dr. Christine as well. And also another important information is the network of marine protected area, which is in Phanga Bay. So that has been our chosen site because this is probably the best marine protected area network that we have currently in Thailand. After that, I think this is the major factor that really pushed Star Thailand into play. So we have very strong government support and also involvement and ownership and very hands-on. So we are led with Department of Marine and Coastal Resource. They have been our focal point, and we also got an endorsement with the Department of National Park and also the Department of Fisheries. So we have been working together with the team, both the field team going down to report receiver or a lot of many things. So this has really accelerated, and after that, we have identified in-country partners aquarium that actually has viable breeding pairs. So we work together with the Reshark partners to collect genetic samples to ensure the correct subpopulation. And after that, we realized that, okay, now we got the shark, now we have to build something to put the shark in and trying to acclimatize them. So we launched the Star Project Thailand just last year in May 2025. And after that, it has been very crazy so far. Like, it's been events after events every month. And okay. And for the acclimatization, actually, we have one of our shark dandy here as well, presenting the poster on Monday and February. I don't know where that came from. Monday and Tuesday. And because our sharks is left in aquaria and has been breed in aquaria, so we would like to shift them from live food to encourage foraging behaviors. So as you can see, we buried snails in the sand, and we also see that there are some exploratory behavior of our sharks. So one of our sharks actually picked up the sea cucumber to try and eat it, which did not succeed. And also there's one time when we were looking around, seeing that they are slurping up polychaetes like spaghetti noodles, so which is really good to see their foraging behavior. After that, we do a lot of acoustic tagging as well. So all of our sharks are acoustically tagged, and we deployed acoustic receivers arrays together with the government. The receiver tagging is also done together with the Reshark partners, Hong Kong Ocean Park, together with the government vet team. So this is also capacity building, and also we have our first marine acoustic arrays in Thailand, which is currently under the MOU to work together and support the future research. If there's any tagging happening, we can all use the same. And I just would like to show you a little bit of an early result. So we released 7 sharks so far, and we've seen from the last download last month, we've seen 5 of our sharks in the receiver race, and one of our sharks actually swam 45 kilometers in one day, which is really crazy. And they are going everywhere in the Phanga Bay, so as you can see from the photos. And this is really a good sign that they are really being able to forage in the wild, and our longest record is 6 months and a half. So this is a really great sign. And lastly, I just want to leave you guys with the take-home message, and the government hands-on really accelerate the project. Really strong communication is very crucial. A lot of collaboration between multidisciplinary is really important to kick this off, and also the Reshark framework is really scalable and adaptable. And I really thank everyone for letting me being able to do my work. And also I'd like to thank our funder, partners, collaborators, citizen scientists, and everyone, and would love to end with a wild aid model that conservation is a team sport. Thank you.
Thanks very much, May. Don't run away. You still have time for a question if anyone has one. Any questions for May? Take one in the back there.
Hello, wonderful presentation. I really enjoyed it. My question is, does the extended human interactions in the beginning have any effect on kind of the human-wildlife conflicts after they're released back into the wild?
You mean when they are in the aquarium?
Or when they're being raised in those tanks for the first moments of their life?
Okay. I think there are, because we acoustic tag them, we've seen that they are growing in a lot of places, and some of those places are not exactly swarmed with people as well. For example, I don't know if we can show the slide, but the Got Mali is also some place where it's not a diving site at all. It's quite close to the mangrove area, and the water is really murky, so I don't think they really attach to human or really imprint on human, but definitely they shows that they know who their human are, but not exactly going towards human because, yes, thank you.
Thank you so
Thanks,
much.
May. Thank you, May. And last before the break here is Riley Pullum, who's going to switch to a different species which is being rewilded or hoped to be rewilded soon, the bowmouth guitarfish.
Thank you. I guess I'll start by thanking Nesha and May and the whole STAR project team and everybody that's been involved with that over the years. It's really paved the way for the work that I'm going to tell you about now, which switches gears a little bit to a very different species from the Indo-Pacific leopard shark, and that's the bowmouth guitarfish. And of course, thanks to all my co-authors and all of our collaborators on this work as well. So this paper by Bolam et al. From a couple years ago points out the fact that targeted recovery actions are needed for species in addition to mitigating threats. So there can be a lot of situations where even if we mitigate the threat, which as we've seen this week is fisheries for sharks and rays, there can be situations where they don't come back. For example, if we see Ali effects and if sharks are fished to a point where they're so rare that it's hard for them to find a mate, then they might not even recover even if we get the fisheries issues mitigated. Further, there's a position statement that came out a couple of years ago by the IUCN Species Survival Commission that really calls on an increased role for zoos and aquariums to take more action in terms of species recovery work and for the conservation community to work more closely with zoos and aquariums to do this work. And I think that's gone a long way in the terrestrial world, and we're just starting to see some of the benefits of that in marine conservation. So this is the bowmouth guitarfish. It's got a very large range across the Indo-Pacific, and it's been highly prized for its meat, fins, and actually its thorny ridges, which can be used as amulets and sold as curios as well. And exploitation is to the point that there's been a greater than 80% reduction over the past 45 years. But you've heard a similar story for a lot of sharks and rays over the last number of days. So why the bowmouth guitarfish in particular? So this species is the most evolutionarily distinct endangered jawed vertebrate on the planet. Losing this species would be the equivalent of losing 88 million years of evolutionary heritage. So if we value evolutionary heritage, then this is arguably the both marine and terrestrial most important species to be working on. Further to that, there are 70 animals in about 40 aquariums across 5 continents. So we do have an ex situ population that exists that can help us with recovery efforts. And so the Shark Ray 360 program is an international collective of these aquariums and other conservation organizations to help recover this species. There are more than 30 contributors from 5 continents, including universities, aquariums, conservation NGOs, and fisheries experts. And so this collective was really formed at a workshop at the Shed Aquarium a couple of years ago, where we worked with the SSC Conservation Planning Specialist Group on an ex situ conservation assessment for this species. where it was determined that there are a number of potential contributions that an ex situ population of this species can contribute to recovery. Under preventing species extinction, providing an insurance population and providing a rescue population, demographic and genetic reinforcement, and research and training and conservation education efforts. Whoops. So the Shark Ray 360 group now has two co-chairs, Dr. Lisa Hoops and Dr. Steve Kessel. We have a coordinator that's working with us, and we have a steering committee and about 5 working groups. But there are a lot of data gaps for this species. From an ex situ perspective, the breeding and the husbandry is a data gap, as well as genetic diversity, veterinary care, and age and growth. There are also data gaps in the wild, of course, and that's regarding spatial ecology, population genetics, their diet in the wild, as well as their age and growth again. So our research working group is currently working on its genetics, spatial ecology, diet and nutrition, and age and growth. And our husbandry group is working on ex situ breeding, increased longevity of managed populations, breeding and transfer guidelines, and developing a husbandry manual. We've got a veterinary group that's, again, working on increased longevity, improving breeding and rearing, and developing artificial insemination. And then our communications group is working on elevating recognition of our efforts and the visibility of the plight of this species, and trying to garner some public support for that. We've got an outreach and capacity building working group that's working to establish in-country relationships in the range countries of this species, trying to facilitate capacity sharing and knowledge transfer, and assisting other groups in developing tools and resources. We've done some work on the population genetics, thanks to Emily Humble, Kevin Feldheim, and Chris Dudgeon, where we've determined that there seem to be 2 distinct genetic populations of this species, an eastern population east of India, and a western population west of the southern tip of India. Which is actually a bit surprising to us, because for a lot of other species we have another genetic break on the Wallace's line in central Indonesia, but we're not seeing that for this species, which has implications for where we might choose to do releases. Last year at Singapore Oceanarium, we held a population viability analysis, again facilitated by the Conservation Planning Specialist Group. We didn't focus on a specific site yet for this PVA, but we just looked at kind of the numbers and the numbers that we would need from the ex situ population to put into the wild to get us to a viable population at a generic site. So we are still working on looking at the different variables about a potential release site to try to figure out where that best site might be. We've created a husbandry quick start guide for aquariums that are interested in getting involved, so that if they acquire a bowmouth, they can use this guide to enhance their breeding or their husbandry and veterinary care of the animals. So what's next for this project? There's a lot more kind of R&D that are needed in addition to kind of the relationship building. We want to do more tagging of wild animals across their range. We have an individual at Singapore Oceanarium right now that we're hoping will be the first aquarium-bred release animal. So that's going to provide us with further information on their survivability after release, as well as their spatial behaviors. And as I said, further analysis to determine sites, and then more ex situ research on care, husbandry, and breeding. And with that, I'll just thank all the partners again, and I'll just mention that we are in discussions with Reshark to become a Reshark affiliated project. So we're really excited to kind of join forces with that team and really kind of amplify this work as we move forward.
Thank you, Riley. And we do have time for a question, if anyone has a question for Riley. Over there in the corner.
Hi, I just wondered what other species of shark you think this kind of work would be viable with?
That's a great question. So we are looking at a number of other sharks and rays, and actually I think it's more rays that we're thinking about. There's potential work that could be done on some of the Hymentura species, so the spotted whip rays. We, at Singapore Oceanarium, we've also had some success in breeding some of the guitar fishes, notably Rhynchobatus australiae and Glaucostegus typus. So those are kind of quite high on our list. I know that Mark and the Reshark team have definitely been considering short-tailed nurse sharks in Eastern Africa. That's one species that's also pretty high on the list and seems quite feasible to do in terms of the aquarium care that's needed and the breeding potential. But I think there's a lot of work going on in terms of considering all of kind of the endangered and critically endangered species and which of those might be feasible to do this kind of work for.
Excellent. Thank you, Riley, and thanks, everyone.
Thank you.
Time for lunch, but please do come back after lunch. We have 6 more presentations in this session. See you then.
Okay. Good afternoon, everyone. Thank you for coming for our session today on volunteerism and how it functions as a catalyst for conservation. Thank you. So we are from an organization called the Pearl Protectors, which is a marine conservation organization, which is also a volunteer platform in Sri Lanka, one of the largest towards the ocean, who's going to be doing today's side event on volunteerism and marine conservation. So first of all, I wanted to highlight what volunteerism is. A volunteer, I'm sure all of you may have volunteered at some point in your life, and volunteerism can be defined in different ways according to which part of the world you are from. A basic definition of a volunteer is someone who offers services or someone who does something good for a larger cause without expecting anything in return. So volunteerism can, again, mean a lot of things depending on where you are, which country, which region in the world. But in Sri Lanka, volunteerism is something quite important. In 2019, Sri Lanka was ranked #1 in the world when it comes to the prevalence of volunteers. 46% of our population had volunteered, and that is mainly because of our traditional values that has been persisting for a long time in Sri Lanka. We have this concept of dana, which is basically a genuine desire to do something. Sorry, it's something to do something for a larger cause through Buddhist values, through selfish generosity, and through that we have concepts of dansal and also a lot of blood donations. So in Sri Lanka, 100% of the blood donations are non-remunerated. And also, organ donations in Sri Lanka are quite large as well. It's considered the only country that has been ongoing in hair donation and one of the significant countries in donating kidneys and eye corneas. So volunteerism for us in Sri Lanka is very, very important. And that is how we have sort of found a problem. The ocean is facing a lot of problems. You all know how there's a lot of pollution. Sri Lanka being right in the middle of the Indian Ocean means we collect a lot of waste that moves around, a lot of transboundary waste. So this was our initial reason to start the Pearl Protectors. It was a volunteer platform to see how we can create awareness on reducing single-use plastic. And this started in 2018. And since then, we have slowly started to grow. And it's basically a youth-led initiative in Sri Lanka. It's science-informed, community-led, and also action-oriented. We have a lot of activism that we also involve because Sri Lanka there's a lot of areas of advocacy and activism that is required, especially towards protecting the marine environment. Right now, we have around over 3,500 registered volunteers all around the country, which means when we have an activity or when we have a conservation effort or if we want to mobilize volunteers for certain activity, we usually follow this process. And it starts off with a registration. A simple registration leads you to a volunteer platform, which means that a volunteer would then be informed of any sort of activities through email, and that would lead up to them signing up for the activity. Usually after they sign up for a conservation effort or an activity, they are usually provided a code of conduct, which is important because we have to maintain standards when it comes to activities that we do. And then, of course, we go through a training program, a briefing, depending on what sort of activity we do. And then, of course, finally, there's a reporting, and then we make sure that all volunteers are recognized for the work they do. So these are some pictures of the work we initially started off in. 2018, when we started off, we knew that there was a problem, and we wanted to mobilize volunteers for simple things where, like, volunteers, young people coming in and how they can contribute, a call to action, basically. Simple things like beach cleanups. And also there was this is picture from not too far away from Colombo. There was an oil spill. And so along with the armed forces and the government authorities, the volunteers were on the beach, literally putting gunny bags and soaking up, or these were gunny bags that soaked up the oil. So it was a very rigorous effort that we had to go through to remove the oil from that from this beach. And then, of course, this was something that we are quite proud of. This was a collection of plastic bottles from the beaches, and we collected them all. And there was about 2,000 bottles, and we wanted to celebrate Christmas with a meaningful message, plastic for Christmas, basically. And so this led to a ripple effect of volunteers coming on board and to do more and more creative activities over time. I'm sure all of you may have seen these images. This image was from 2021, the MV Express Pearl disaster, which is considered one of the largest maritime disasters in the world, where nurdles, the most number of nurdles spilled out into the sea, and our beautiful beaches were affected. Basically, it was like snow. So we soon after that mobilized thousands of volunteers who were out in the beaches removing these nurdles. It was not just about volunteer mobilization, it was about technology, it was about innovation, bringing in innovation, and how do we collect these nurdles, little microplastics from the beaches. And so that led to 3 years of activities that we had planned every weekend, volunteers coming out and removing these nurdles over time. And we were able to remove over like 4,000 kilograms of nurdles, little pellets from the beaches. All these happened while Pearl Protectors was expanding, and more volunteers started joining, because one led to good impact, and then that led to more volunteers coming in, and that meant that we could do more volunteer activities. We were not only doing beach cleanups and then, the simple things. We were also looking at like research, because Sri Lanka lacks a big gap in research. And how do volunteers help with gapping the research, or basically the database, conservation-based data, and also doing citizen science. And so all these reports, all publications of the Pearl Protectors are volunteer-led. We have volunteers, we facilitate volunteers for them to learn while they do data gathering and also report writing. So we've actually contributed large amounts of our publications towards advocating for better policies in Sri Lanka, and these were all volunteer-led. So next off, I want to invite Nishad. I want to explain about Turtle Patrol. This is one of the largest volunteer-led conservation efforts in the world, and this has been happening for 5 years. And to explain more about how we do it through volunteers, I would like to invite Nishad. Thank you, Mudita. I'm Nishad, and I just want to ask, how has Sri Lanka been treating all of you? Well, great. Where have you been in Colombo? Have you been to the beach, most of you? This Turtle Patrol, the project Turtle Patrol, is about like urban conservation of turtles, which come and nest along the coasts of Colombo, particularly the beaches of Mount Lavinia, the Hivala, and we've also got turtles in other beaches like Vallavatta and Golface also, which is really close by. But our conservation is focused on Mount Lavinia and the Hivala. Sri Lanka being a small island, an interesting fact about Sri Lanka is that we've got 5 of the 7 species of sea turtles which come and nest in Sri Lanka. And in Colombo in particular, we've got the olive ridley sea turtle which comes and nests. The olive ridley sea turtle is the smallest type of sea turtle, and it generally nests from January to March. And so our patrol, which is like we walk along the coast of Sri Lanka, coast of Colombo, to patrolling from like 10 o'clock to 2 o'clock, from January to March, to ensure that when turtles come and nest, we like essentially ex situ conserve the eggs which they nest, and like at a hatchery which is maintained by the Coast Guard of Sri Lanka. So that's a collaboration we do with the Coast Guard. One important thing now, you might wonder why we conserve this, and we like take the ex situ method of conservation, where we essentially get involved in digging a nest and relocating the nest to another place. It's because Colombo being the very populous city, our beaches have a lot of footfall of people, and particularly we have like people who actually take nests and like poach nests and sell eggs. That is ideally sold to restaurants or even to the public also. In certain instances to hatcheries also. So that they thereafter essentially invite tourists to come and they release the nests into the like hatchlings into the sea. Our project essentially ensures that poaching along the beaches of Mount Lavinia and the Hivala is reduced. Other than that, along that coast from the Hivala to Mount Lavinia, we have a lot of restaurants. It's because that area is sort of developed as a tourism development zone. So at night, you have like a lot of people coming and restaurants putting on their tables on the beach. And we've got like right up to the coast, that is like the high water line, we have like people sitting, like eating food. And turtles also at that same time come to nest. So unless like that area is not really conducive for turtles to come and nest, and like for the nest to be conserved in situ at that location. So that's why we essentially relocate nests to a safe point where we don't have a lot of people. Another important fact is when it comes to light, most turtles essentially hatchlings, when they hatch, essentially go towards the light. And all these restaurants are really lit up. And there's a lot of light pollution and sound pollution. And so the hatchlings are disoriented. And instead of going to the sea, they essentially go onto the land, and there's a rail track also beyond that, and they get onto the rail track also in certain instances. So what we do is we ensure that if like we conserve it ex situ at the Coast Guard's point, then we have hatchlings which we can safely release to the sea after like 7, 8 in the evening. That ensures that this place can be maintained as a sustainable turtle nesting location. It is also, we are like studying, like that is based on the citizen science approach, what turtles do, their habits and their nesting behaviors along the coast of Colombo. And finally, we also conduct a lot of awareness programs. 1, to the beach goers, 2, to the restaurants which are there, 3, there's a small fishing village within the coast. So we also interact with them and ensure that they are also educated on like turtles and their behavior and how important it is to conserve. Next, we'll watch a short video about our turtle petrel. So volunteers do come to the turtle petrel from different locations of Colombo, not only the vicinity. If you see there, those are the restaurants which we have. This is my 5th year patrolling. We started off with a dozen volunteers, and this year we have around 300 volunteers. And I've got to experience how the turtle patrol grew from a very small group of volunteers to a big group of volunteers who volunteer every night from 10 o'clock to 2 o'clock.
The main difference from last year and this year is that we have extra measurements that we are taking.
One is the sound pollution and the second is the light pollution. Whether these two parameters may affect the turtle nesting season and their behaviors.
Yeah. And we take these measurements about 2 to 3 times a week.
We also took measurements of the turtle carapace size as well as the depth of the nests.
What we do is we collect them and we enter to our app and we will be doing a report.
මම ආවේ සාගර විශ්වවිද්‍යාලයෙන් ශ්‍රී ජයවර්ධනපුර විශ්වවිද්‍යාලයෙන් මම ටර්ටල් පෙට්‍රල් එකට සම්බන්ධ වෙන ෆස්ට් ටයිම් පළවෙනි
first time
පළවෙනි
First time.
ආව මේ වගේ වොලන්ටියර් එකකට ජොයින් වුණා මේක මට හොඳ එක්ස්පීරියන්ස් එකක් මම කවදාවත් ටර්ටල් කෙනෙක්ව දැකලා තිබ්බේ නැහැ ඇත්තටම
இங்கே வந்து தான் டோட்டல் எக்ஸ் எப்படி இருக்கும் எப்படி கலெக்ட் பண்ணுறது எதுக்கு சேவ் பண்ணி என்ன செய்கிறோம் அதை பற்றி தெரிஞ்சுக்கிட்டேன்.
I saw for the first time hatchlings in just random spot crawling out, and so this was a very special occasion.
මගේ පස්වෙනි දවසේ තමයි මම ටර්ටල් කෙනෙක් මුලින්ම දැක්කේ. ඉතින් ඒක ඇත්තටම හරිම අලුත් අත්දැකීමක්.
මම ඒ ටර්ටල්ලා දැකලා තිබ්බා ඒ වුණාට ටර්ටල්ලාගේ බිහේවියර් එක දැක්කේ මේ පෙට්‍රල් වල.
කලින් අපි කැස්දාව ගැන ඉගෙනගෙන තියෙනවා ඒ වුණාට ප්‍රැක්ටිකලි අපි ඒ දේවල් දැක්කලා ඒගොල්ලොත් එක්ක එකතු වෙලා ඒගොල්ලන්ව සංරක්ෂණය කරන්නේ කොහොමද පිටර එකතු කරන්නේ කොහොමද මේ හැම දෙයක්ම මේ වැඩසටහන් තුළින් අපිට ලබා ගන්න පුළුවන් වුණා
අපේ මුහුද සාගරය වෙරළ ඒ ආශ්‍රිත දේවල් සංරක්ෂණය කරගන්න මට අලුතෙන් දැනුමක් ලබා ගන්න පුළුවන් වුණා වගේම මට මේකට දායක වෙන්න ලැබිච්ච එකත් ලොකු ආසනාවක් කියලා මම හිතනවා.
Most of it I'm actually learning a lot about everything, about how to handle turtles, about what is right and what is wrong, or what is seen as right and what is seen as wrong.
මිනිස්සු හොටල් ආශ්‍රිත කරන රැකියා සහ ඒගොල්ලෝ කොහොමද මුහුදත් එක්ක ගැටෙන්නේ සහ මුහුද කොහොමද අපි ආරක්ෂා කරන්නේ මේ හැමදේම ගැන ලොකු එක්ස්පීරියන්ස් එකක් ගත්තා.
Next I hope you enjoyed the video. Next I'll go into the volunteer involvement section. We started with a dozen volunteers initially in 2022 and now we have around 300 volunteers who signed up, of which we had around 150 who completed at least 10 patrols. So we required each volunteer to volunteer at least once a week. So we had like 12, which is 3 months, means we would have 12 weeks. So we had 10 days each week a volunteer would have come. So which I think is a very big number, and we divided our like patrolling location into 3 coasts, that being Dehiwala North, Dehiwala South, and Mount Lavinia. And we had a team for each of those locations with at least 4 volunteers in each team. So we had like 21 teams on like all 7 days, and they used to patrol from 10 o'clock to 2 o'clock. Sometimes it doesn't stop at 2 o'clock, it goes on until 4 o'clock, 5 o'clock, if a turtle comes. It's because quite often turtles come after like 1:30, and when we are about to go, they are there. And we sort of have to sit and like wait till they hatch and finish off the hatching session. What we essentially do is, why it is important is, one, we like control crowds. So we are trained, and we like ensure that our volunteers are also like ensure the turtle isn't disturbed. So we have like protocols like where if a volunteer sees a turtle, he should ensure that beachgoers at least stay 20 feet away from the turtle, and they are not disturbed while they are hatching. We also train them on how to collect data. And we also like essentially discuss with all the beachgoers and the restaurants on how we can ensure that these turtles are well protected when they come and nest. So this is the impact we had in this year. We had 7 nesting sites in 2021, and though we only patrolled for 1 week, but when you look at 2026, we've got conserved 17,000 eggs, and 156 nests were protected. In 2025, we had 202 nests, and 21,000 eggs which we had conserved. So you can see over the period, this organization, this like group, which was really small, has grown into something really big. And we've got a lot of volunteers also we've retained a lot of volunteers over the years. And at least half of the volunteers who patrolled last year would have continued on this year also. Another important thing we did was like technology, citizen science, and conservation. This app, which is like this is the Turtle Patrol app, that's what we call it, is something a volunteer developed to ensure that when we patrol, we ensure that we log our turtle patrol. So what time it starts, how long the patrol was. We also like locate where the turtles come and nest, that location. If we like find any incidents, we also like record that. Additionally, we also use that app to essentially like track like patrollers, attendants, and generally communicate also. We also use like WhatsApp and everything, but the Turtle Patrol app is essentially a volunteer developed app for our patrol. Another important thing is like we also do research, and which is like essentially why initially when we started in 2022, we didn't essentially focus much on the research aspect. But over the years, we have also been, each of us, all the patrollers have been learning a lot about sea turtles. And we've also focused in trying to like move into an area where we can essentially do some research and really learn about turtles also, to ensure that when we conserve sea turtles, that such conservation is really meaningful. So essentially, we also know that like a traditional researcher would not have the ability to go on like for 3 months every day to patrol. But we have volunteers who are really willing to go up and down. So we sort of bridge the gap by actually training a few volunteers as research assistants, who would also go up and down with the volunteers, and we have like a pool of 20 research volunteers this year. And they essentially lead the patrols, and they are the ones who would collect data. And we've also developed certain protocols on how to conserve, in the sense, best practices based on best practices of like IUCN and generally research in India and Sri Lanka, also in other locations, to identify how we should ensure that that turtle patrol is conducted in a safe way, which is safe to the turtle and to the patrollers also. So one important thing when it comes to the turtle patrol is that it sort of gives scientific evidence, guides conservation, but only collective citizen action sustains it. So without people, even the best science cannot protect the environment. So it's on that principle where like citizen action is essentially needed. And every citizen getting involved would ensure that we would have a better turtle patrol, and we could conserve that beach also as a turtle conservation location. Volunteer recognition. Before that, I would also want to speak that we also publish a report. That report is based on our findings. So this report is essentially written by volunteers. Mostly this year, I had the opportunity of writing it, co-writing it with others. And my background is not necessarily science. I am a lawyer by profession. And we've got like Mudita, who is an economist, and Rose would speak next, is a financial accounting professional. So we are from different fields, but we come and like learn, and essentially we have like tried to ensure that we are able to like conserve sea turtles in a scientific and good way. We also have like collaborated with the University of Colombo to ensure that our research is good, and like to like ensure all gaps in our research is like covered, so that we have like a sound research. The final thing is recognition. Mudita generally really favors recognition. For me, I would say that patrolling in itself is the biggest recognition. You don't necessarily need recognition. We do fight for a cause. But one thing I've observed is that like a lot of volunteers, everyone who have come, is that at the end of the patrol, we have a recognition ceremony. And they are all very willing and very happy to come to that ceremony. And like that recognition is something they do value a lot. And we do give them small gifts and vouchers also, so that like they're appreciated. And that's how volunteer recognition is there. Even the smallest recognition is something they appreciate a lot. Next, I will invite Rose Fernando to speak something like in terms of volunteering is where the bar is set a little higher, at least 200 PSI, where it starts at.
Thank you, Nishad. So I'm Rose, and I am the expedition lead for the Cleaner Seabeds for Sri Lanka initiative. So I am a management accountant by profession, but I love the ocean so much. So here I am, volunteering with the Pearl Protectors for the past 5 years. So what is Cleaner Seabeds for Sri Lanka? So this is a 100% volunteer-led initiative where we focus on getting recreational divers to become volunteer divers so that they can work on something that will create an impact. And why did we start this project? It's because we saw the challenges that our reefs are facing from ghost nets and from plastic waste, because there's a lot of rivers that flows into our ocean that carries a lot of plastic pollution. And also Sri Lanka is Sri Lanka has a lot of fishing industry, so fishing activities. So because of that, our reefs are anyways threatened. So we wanted, as volunteers, to do something about it. This is the actual problem that we are tackling. So it's not only about Sri Lanka, it's a global problem. So every year, more than 600,000 metric tons of ghost fishing nets or discarded fishing gear is being released to the ocean. And more than 1.7 million metric tons of plastic waste is being released to the ocean. So Sri Lanka being a very small island, we have a lot of challenge to protect our marine environment for our future. So this is the reality underwater. The first video, you can see this is a wreck, a famous wreck in Colombo, how the marine life is affected by a fishing net that is entangled in this wreck. And the next video is of us doing a cleanup dive also in off Colombo, collecting plastic pollution. And this is our divers in action during one of our cleanup dives, removing ghost nets. So these are the dive sites that we have cleaned, and we are continuing to do our future dives. So during it's the west season, west coast, we make sure that we do cleanups in the west coast, and when it's the east coast, we move to the east coast. And the most important thing here is to the before and the after effects. So you can see in the first picture, the coral, the reef system is dead. There's no marine life. It's just covered in a ghost net. This is in the east, that's Trincomalee. And after we clean the net, you can see how beautiful the reef looks like. And us as divers, we are so privileged to see this firsthand because we are blessed. Like the moment we clean the reef, the moment we collect all the ghost nets, and the moment we start ascending, we can see the marine life starts coming back to their home. The reef's thriving. And I think that's the reason most of us are volunteering for these efforts, because it gives us pure happiness. Cleaner Seabeds for Sri Lanka is not just about volunteering. So it's more than that. It's more than diving. We conduct underwater surveys to understand where there's pollution, where the reefs are threatened. And also we conduct surveys to understand how corals are growing, the density of the corals, to help our research students. And the most important thing is community awareness and education. So we conduct community awareness sessions with the fishing communities, schools, and coastal communities to help them understand what are the best practices, what are the things that they should not do. We have conducted public events for communities, for people to showcase what's the real threat that our reefs have in Sri Lanka. And whatever the garbage, whatever the ghost nets that we have collected, we have tried our best to upcycle it, partnering with certain organizations in Sri Lanka. And also, the most important thing, advocacy and data gathering. So we collect data from all our dives, and we compile our data for future policy changes, to push regulatory changes, and to support and to make evidence-based decision making. And the power of our Cleaner Seabeds for expedition is our divers. So without our divers, we won't be here. And one of the biggest strengths that we have is our divers' knowledge that our divers bring. So we have divers coming from all over the world, bringing different sets of experiences. So we have master divers, dive instructors who have come from all over the world, teaching us little things on how to remove the nets correctly, how to control your buoyancy during a cleanup, or it could be how to tackle an emergency situation. So all of these have actually helped us to make our dives effective. And we are so lucky that we have a big dive pool, like pool of divers. So we don't see strangers each time we dive. We see familiar faces because our divers keep coming back for each and every dive because they know the impact that they are making when we do these cleanup dives. And each diver has a multiplied impact. Like I explained in the previous slide, each diver contributes more than a cleanup dive. They do surveys, they do community awareness, they contribute for upcycling events, they do advocacy. So each volunteer impact is always multiplied. And lastly, our volunteers act as our awareness leaders. So they create awareness among their friends, among their peers, families, and they encourage their friends to join us to dive. And sometimes they inspire their friends to get their diving license. So they act as our awareness agents. So we started this project back in 2021. So for the past 5 years, we have conducted more than 100 dives, and we have mobilized more than 350 volunteers, and we have removed more than 2,000 kilos of discarded ghost fishing nets from our reefs and more than 600 kilograms of plastic waste. So our concept is simple. We intend to remove marine debris from our reefs in order to protect it, and to upcycle whatever we can so that we can add some value to the waste that we are removing. And also, most importantly, to prevent these happening again, we intend to educate our communities, to make our fishing communities more aware of what's the real threat the ocean is facing. So to continue further, I would like to invite Mudita. Thank you.
Thank you, Rose. Thank you, Nishad. So I hope that was quite insightful for you, all of you. These were some of the large-scale projects that we do, the Cleaner Seabeds and the Turtle Patrol program. But beyond that, volunteerism in Sri Lanka helps towards education and awareness, and that is exactly what we are doing as well. We are an island. The ocean is all around us, but Sri Lankans' connection to the ocean is only very limited. And so that is because not a lot of Sri Lankans do get out into the ocean. So we have a problem of bridging people. How do we do that? And we have used volunteerism as one of our bridging tools. We do a lot of awareness and education. And these volunteers coming in and volunteering are also supporting in creating positive education and creating that inspiration that a lot more Sri Lankans are needing. Now, this was South Asia's, I guess Asia's largest blue whale sculpture that we made last year to celebrate World Oceans Day. This is because we know in Sri Lanka, blue whales, especially whales, are facing a lot of challenges because there's a lot of swimming with whales, illegal activities going on. And so by doing these programs, educational awareness programs, we've managed to capture the Sri Lankan audience and to make them aware why there's a big problem and why they need to act towards protecting our marine environment. Every year we celebrate World Ocean Day. Not just that, every year we do a lot of awareness programs. We go to schools, we go to universities, and we talk about the challenges that we face. And most of the facilitators for most of these awareness programs are volunteers. Volunteers who have contributed, who keep on coming and volunteering. And so it's not just volunteers, they become ambassadors of education as well. So I want to kind of narrow down on some of the key things that we learned today. Volunteerism. So if you are to provide volunteers, or what you need to do if you want to make it more effective within your organization, and if you want to promote volunteerism, and if you want to do it the right way, these are a few guidelines. First of all, leadership. I think Sri Lanka, globally, we are lacking leaders. And one good way to have more good leaders is through volunteerism. So show the way and let them lead. Next, the passion. There has to be a passion. There has to be inspiration. Let that passion drive the work, the conservation work that any of you do. That will create a ripple effect in getting more volunteers, a lot of young people on board. Recognition. I think it's important that every work a volunteer provides, especially if they're doing it without expecting any monetary gains, as an organization, it's important that you recognize and also let them network. It's always good for them to know that there's a larger purpose in what they do. And building connections is always good for your organization as well as for the larger conservation globally. Knowledge is also important. It make your organization a learning hub. Let volunteers who come on board learn. Let them make it an incentive for them to learn. So these are some of the five things, the top 5 things you probably should do, or what you need to focus on if you are going to be having volunteers. In utilizing volunteers, you have to always have creative solutions. It's important, like, fresh ideas usually come with young minds, new minds. Make it a movement, not just an organization, but make it more activism-based, make it a movement which has a positive impact on keeping that passion, that inspiration going. Find gaps. Sri Lanka, we face a lot of gaps when it comes to research, when it comes to enforcement. We see how volunteerism can bridge that gap, and that gives us a larger objective in why we mobilize volunteers. Maintaining consistency. This is an overall problem around the world. When it comes to conservation, sometimes it can be just a few years and then it ends. But then making sure that there's consistency means that more and more volunteers can be attracted. Celebrating impact. In conservation, we always have that end impact, and it's important that we highlight it, we celebrate it. That way, there is going to be more and more volunteers also being inspired to continue their good work, and they could replicate the same project maybe in their own communities as well. And also finally, building community. Sri Lanka, our challenge initially was, how do we bridge the ocean with the people? How do we make people understand how important conservation is? And the best way we were able to do it was through mobilizing volunteers, because they become, again, ambassadors in their own community in getting that message out. So it's important that you focus on the community as well. But of course, everybody has challenges, and when it comes to volunteerism also, there are challenges. I'm sure you may have encountered some of these challenges before. One of the biggest challenges we find is lack of consistency. This has happened to us also when it comes to projects that we want to do in a long-term sense. So how we have been able to cope with it or overcome that challenge is by having recurring calendars, maybe reminders and notifications, and also having a drumming to the event coming up or an activity that is coming up that creates excitement, and that is what could lead to more consistency. Volunteers who come to support, of course, they might be passionate, but they might lack in experience and also knowledge. So this is also something that we have also encountered. It's because some of the conservation work we do is also requiring an excessive amounts of knowledge and training. And so how we have worked around is by structuring, having a proper training, briefing sessions, and structuring onboarding of volunteers. That gives the volunteers more reason, more understanding of what exactly they are required to do. And having mentor pairing is also very important, because they can always look up to someone when they are doing it. Especially when it comes to turtle patrolling, we have these activities going on, which means that volunteers keep on coming year on year to come and be turtle patrollers. We also may have encountered reduced self-discipline. So this is, especially when the young people are coming on board as volunteers, you may always have issues when it comes to professionalism. So how we work around it is by providing a progress card, a volunteer progress card. So every time they come and volunteer, we kind of record their volunteer activities, and also public recognition. Giving them that recognition means that they are in the public's eye. That gives them the incentive to be more professional when it comes to conduct. And also we maintain a code of conduct. So every volunteer has to abide by the code of conduct whenever they are volunteering. Time for guidance. It's a problem for all of us, isn't it? Because we have to commit our time towards conservation, and then also having volunteers being trained can be an excessive time commitment. So having a trainer, train the trainer is a possible way to overcome this. We have a volunteer manager who overlooks these areas, and having digital resources. Having digital resources means that you can always provide them guidance through a digital platform. Sustaining motivation is a big problem. We see that volunteers, of course, come from different fields, different aspects. They come and volunteer because of the pure satisfaction they would get. So here, always good ways of overcoming these challenges of sustaining motivation is through sharing results with them, giving them that purpose that whatever they did has had a good positive impact through conservation. Celebrating milestones is another way we do that. Every year we do it with Cleaner Seabeds for Sri Lanka. When it comes to turtle patrolling, we do this for Ocean Day and for other work that we do as well. And giving career pathways, that's very important. In the time we live in, there's a lot of problems, challenges the youth are facing when it comes to career guidance. So it is important as an organization providing that platform so that they can build their own career. And finally, why conservation through volunteerism? So these are top 10 sort of aspects as to why volunteerism is definitely the way to go when it comes to conservation. In Sri Lanka, we have the Department of Wildlife Conservation, and one of the biggest challenges they are facing is that they have a lack of human resources. When it comes to marine environment, they have very limited numbers of people who are capable of doing monitoring and enforcement. So this is where volunteers come in. And we as volunteers, during the night, during the day, we act as citizen scientists, we do the data gathering, but also help the department by being the eyes on the field and helping out with the conservation. Cost effectiveness. So there's a lot of organizations that could be impacted because of financial crisis or situations. Volunteerism is a really good way to sustain and continue the conservation efforts through a very cost-effective and a scalable way. It's a very good citizen science platform and a very good data gathering platform. When we had the MV Express Pearl disaster, we had volunteers who were gathering data from all around the country, who were submitting data of where the nurdles are, and whenever there's a beaching of a sea turtle, they would be reporting to us. Even now, when it comes to transboundary marine litter that falls onto our beaches from other countries, it's the volunteers who would take a picture and send it to us. That creates a large database, which not a normal expertise, a scientist or an expert would be able to do. Community ownership is also a very important aspect. It creates stewardship by community participation. And especially in Sri Lanka, where we have different communities in different parts of the country, community ownership of what they do actually helps sustain conservation efforts. Awareness and education is a very important aspect as well, because volunteers become ambassadors of education. They start educating their own community, and they also share stories. Stories are a very good way of awareness. And so volunteers carry the best stories. And so this creates a ripple effect. Next, of course, is bridging between science and society. The bridge is widening, and one of the best way we can bridge this is through volunteerism, having those volunteers as ambassadors of learning. Diverse skills and creativity. Sometimes volunteers with their young minds, like I repeated before, brings in a lot of creativity, enthusiasm, motivation. That helps us to, any organization, to think of the solution out of the box. And also, Sri Lanka is a it's a tourist hotspot. We have a lot of tourists coming in. We can also look at eco-conscious tourism, where tourists come in and contribute towards conservation as well. And this is also another form of volunteering. The cultural transmission is very important. For example, when we are at the beach, we talk to a fisherman. A fisherman would say, "Oh, the next week, it's going to rain." These are historic traditional learning that fishermen have learned it for a very long time. And so when volunteers are actively engaging in conservation, they open up these communication methods with the fishermen, or it could be anyone from the community that could transfer or provide that historic information that could help better perform conservation efforts. And also better monitoring. Sri Lanka, again, like I said in the beginning, we lack in our enforcement. It's a big challenge. And what we've seen is over time, it's the volunteers who report. Whenever there's illegal activity going on around the country, whenever there's unethical activity going on, say it's with sea turtles, with dolphins, or whales, or even could be anything, it's volunteers reporting, helping the authorities to take action. So these are why volunteerism is very important for conservation. And for us, that brings our session to an end. I hope all of you can contribute to volunteerism and promote volunteerism in a very positive way. We are carrying out our work through conservation with the support of volunteers, and we hope to do it in the future as well. Anybody who would like to volunteer with us, you can always scan the QR code and register with us, and you can, whenever you are in Sri Lanka, come and volunteer with us, and you'll see how amazing volunteerism is in Sri Lanka. With that, thank you so much for everybody for listening in, and if you have any questions, we are open to any questions. Thank you. Yes, go ahead.
Hello, thank you. Yeah, that was very interesting and great to hear about the work you guys are doing. I guess a bit in a way of the elephant in the room is how do you guys ensure that, you know, we're a country that's quite diverse socioeconomically and in other ways as well. And of course, not everyone has the time to come and volunteer, even though they're passionate about the ocean. Do you guys do anything to make sure that that there's a reason for people to keep coming back, and other than solely just the passion and companionship?
Well, that's a very good question. I think nowadays the youth participation, especially when it comes to environment, can be considered challenging for them because of the time constraints they may have and the pressure that the society is building up onto them. But the ways we have actually worked around this is through providing career guidance as to how they can structure their life into the future through conservation. And so we try to create volunteerism as a stepping stone. And that has led to a lot of university students coming in as volunteers, especially a lot of young people between the age of 18 to 25, where they also see that there is a big problem. Of course, everybody can see that the environment is going to be challenged in the coming years. And so, of course, that could create them opportunities where they could pitch in and help support. And so for that learning stepping stone is through volunteerism. And by making them understand that, we have found a way to keep them sort of motivated to keep coming. But then, of course, like, you know, I understand the other side of it. It's very difficult. We had the COVID during the COVID time, and during the economical crisis in Sri Lanka, we saw a decline in volunteerism, but we also have seen the uptick as well at different times as well. So you have to also understand how externalities could affect the youth and the young people in coming towards these initiatives.
Thank you. That was a great answer.
You're welcome.
Yes, this has been an amazing talk. In fact, I wish that everybody from the conference was here, because I've been working in Spain for over 10 years on volunteering through the Scouts movement, and you've made a very great talk showing all the aspects, very educative about it. Yesterday we had a meeting about the UCN specialist group, and they were asking the public what things are needed in the future to better protect shark and rays. And not so many people commented about the natural connection that society has with nature. So we feel like worldwide our communities are getting farther away from nature, losing nature connection. And what you showcase, and everywhere in the world, through volunteering, you are putting the people in contact with nature. So I wanted to ask you, are you measuring the impact when a volunteer decides to go with the turtle patrol, and a year, 2 years later how their view of turtles have changed?
So you're asking them, are we measuring the impact of volunteerism compared to how conservation changes?
No, the individual that in the beginning they don't know nothing about turtles, then they see your institution, decide to go, and then are they seeing turtles in a better way? Are they talking about turtles? They become ambassadors of the species?
Of course, 100%. I mean, this is how we have been able to have the conversation started in Sri Lanka. So going back to sea turtles, 7 years ago, Sri Lanka's hatchery industry, it's a very lucrative industry. I'm just openly saying this. It's not the most ethical and the most conservation-friendly ways of having sea turtles. Of course, these sea turtles come to hatcheries through fishermen or some lucrative way. And so a lot of people thought, oh, it's conservation, these places are doing good things. But through the years, through Turtle Patrol, what we have been able to show is that there's an alternative right way of doing conservation. And that learning, the word of mouth has spread across Sri Lanka that now a lot more people are now questioning what is happening at hatcheries. And so it's a silent voice that was able to spread across, not through any means of advertising, not through any sort of visibility, but just through word of mouth. And hundreds of volunteers coming and seeing it themselves, the impact, how sea turtles are effectively, I mean, these are reptiles and they are facing a lot of challenges, and how through these programs they have been able to conserve and protect them the right way. And you see these wrong things, by practice, then they start questioning. And so this same example can be replicated into many other conservation areas, especially when it comes to diving, when it comes to underwater pollution. There's aquaculture, unsustainable aquaculture practices in Sri Lanka. There's so many that we've been involved. Through volunteerism, that message has spread across. And even in universities, we hear that students are openly questioning right practices versus the wrong practices that are continuing. And that is purely through their engagement of conservation efforts. Yes.
Thank you. Thank you for your amazing insight. So I was wondering about, I was thinking like, when you're eager to do some volunteering, you need to have your basic needs fulfilled. So what do your opinion about that? And another thing that I also consider about the volunteering, that's in the future, all the job provider need to be considered also the volunteering as one of their value about how they assess the job seeker. That's also important that need to be advocate more and more. Thank you.
Could you repeat the first question?
Oh yeah, sorry. So I would say that when you want to be volunteer, your basic need to be fulfilled, right? So your basic needs need to be finished. You're finished with yourself, and then you start, okay, I can do something for my community. So what do you think about that, especially in Sri Lanka? Thank you.
That's a very good question. I think volunteerism, again, changes from different country to country, maybe region to region. I was in United States, and I know when I was volunteering in United States, I remember volunteering was based on volunteer hours. And also it was sort of seen in a negative sense because it was sort of like a penalty, like if it's a punishment, like go and do volunteer hours. That is what they say. And so that is being looked in a very negative sense as well. And it could be different from Southeast Asia, how volunteerism works. So region to region, volunteerism works. But in Sri Lanka, volunteerism has been a genuinely engraved cultural practice throughout the history. And it doesn't mean that volunteers or young people have to have their basic needs accomplished before they come to volunteer. They actually do it while they have other challenges going on. But they use volunteerism as a way of self-satisfaction to help find that energy to deal with other challenges that they have in their own lives. So when we meet, when volunteers, like-minded people come together, they discuss discuss those things as well, which helps those young people to overcome some of the challenges that they may face. So Sri Lanka, like I said, has a high population of people volunteering, and they look at in a very positive way. So, and also they want to be engaged, especially during the recent Ditwa cyclone. We saw thousands and thousands of volunteers just coming out, pouring in their efforts when they had their own challenges, when they had their own houses broken down and affected due to floods. They still came and volunteered. It's the same thing during the past tsunami. After the tsunami, we saw so many volunteers coming in. They did have their own challenges, but they still continue to come. So I think the question might vary from different place to place, but in Sri Lanka, we have that sort of genuine sense of contribution overall. Thanks. Anybody else has any questions? Yeah.
Thank you. Really good presentation and a really good job. Have you considered to formalize yourself to? I think I just continuing from Mas Andika question there about the sustainability of the work, and you said that in Sri Lanka the volunteering comes from heart and everything, but at the same time you just you mentioned a slide of two about all the challenge in volunteering. So I think my question is, have you suggested to formalize yourself and ask for support from government or funders? I think in the next room there's a bunch of funders that really interested in helping you. Just try to get yourself support, and maybe if your volunteering action get some support, and people will, and young people or everyone will see it as this is sustainable. Your effort, your volunteering effort is I can get a living with this noble cause, so something like that. Yeah, thank you so much.
Thank you. No, I think that was a good point. I mean, what we are trying to also see is how can volunteerism can actually be structured in a way where it can help towards conservation. And so again, it comes down to where we showed some of the basic requirements that should be fulfilled in any organization. If you are having volunteers, how you prioritize volunteerism in your organization. But then again, coming back where you're coming from, depending on which country you're coming from, it's good to understand your cultural values as well as to how you can bridge the structure with volunteerism. So to make it the best, most effective way of how to motivate volunteers, I think it's important the culture, historic values of volunteerism, and then the structure being combined. So I think you can do really good stuff from that combination. Thank you. All right, so with that, thank you so much for listening, and happy volunteering, guys. Thank you.
South Africa. Kevin, take it away.
Thank you, everyone, for making it here after lunch, and welcome to the last session. So I'd like to just tell you a little bit more about the raggies that we have been tagging and releasing between 2012 and 2023, and this work also forms part of my master's. So where are we? Two Oceans Aquarium is located at the southern tip of the African continent. We are based in the V&A waterfront in Cape Town. And the Two Oceans Aquarium opened in November 1995, and we display a high diversity of both local and endemic species, and this is due to two contrasting currents that we have on our coastline. So on the east coast, we've got the warm, nutrient-poor tropical waters that gives rise to some coral reefs along our eastern coast, and then we have our cold, nutrient-rich waters along the west coast, and that gives rise to our kelp forest. So currently we house various species of sharks at the aquarium. These do include our shy sharks, cat sharks, gully sharks, and of course the ragged-tooth sharks. We also do display various species of rays, so I haven't forgotten about all the ray people. So our release program started with Maxine. She was the very first raggy that we released, and this was in 2004, and she formed part of the work that was done by Smail et al. And she was used as the start of the ambassadors for her species and for sharks in general, just to raise public awareness and about the plights of sharks around the world. So my MSc is looking on the movements of previously captive ragged-toothed sharks that have been released from the Two Oceans Aquarium between 2012 and 2023. And by using acoustic telemetry, I'll be able to assess their movements across different size and as well as sex classes. And I'll be presenting on some of the findings of the males and females. So just a brief, the ATAP network covers roughly 2,300 kilometers of coastline along South African. There are approximately 300 receivers that are deployed. Majority of these are in the shallow inshore regions, less than 30 meters, as well as a few estuaries. My study site ranged from False Bay in the west through to the Mozambique border in the east, and was divided up into 11 regions. So the sharks in the study were all from one of 4 locations, and these locations were generally chosen for ease of access for our truck, as well as the associated life support equipment. When a shark was deemed ready for release, and this is normally dictated by size, we will remove that animal to our quarantine facility where they were anesthetized to a safe level to be able to take morphometrics and for our vet to do a full clinical exam. The surgical procedure was done by our on-site vet, and we used V16 acoustic tags with a 7 to 10 year battery life. The incision site was then flushed with sterile water, and a local anesthetic was injected. The incision was made eventually through the abdominal wall, and the sterile tag was placed into the coelomic cavity. The incision was then sutured using absorbable suture material. When it came to release, we had 3 release sites in the Western Cape, 2 in the Eastern Cape, and 1 in KwaZulu-Natal. That one individual that was released in Durban, KwaZulu-Natal, was an exception. She had developed a slight infection on the incision site, and we were about to undergo major renovations, so we were unable to house her. So with some collaboration with the Shark and Marine World, they agreed to house her until she was healthy and ready for release. At release, the PCL of males was slightly smaller than that of females. So in total, we tagged 37 sharks. Males were housed at the aquarium for slightly less time than females. And we had 80% of our males have been detected, 81% of our females detected, and that's at 2 or more locations along the coast. So in total, we have over 170,000 detections. And this abacus plot, you can see there's a huge variation in that data. So we had some individuals that went 3 to 5 years post-release before their very first detection. We've also had some individuals that were detected and then disappeared for up to 3 years before being redetected. And then we had some overachievers that were detected almost continually throughout the study period. So this just again highlights variability of these detections, the importance of choosing your correct tag, as well as the battery capacity for your studies. In terms of detections, so this is the detections for all our sharks along the coast. There's a large overlap in habitat use, mainly between stray spy in the south coast and proteobanks in central KwaZulu-Natal, between males and females. This range is pretty much the natural range that ragged-toothed sharks occur in along our coast. And we also had detections in 2 major estuaries on the south coast, namely the Breda River and the Knysna estuary. For the Breda River, we had 1 male. He was detected almost 9 kilometers upstream. This was for multiple years and throughout the year. And in the Knysna estuary, we have 2 females that have been pretty resident there. Even recently, there's still been some detections, and again, traveling about 9 kilometers upstream for multiple years and throughout the year. For regional movements, this chord diagram just kind of highlights the variability in habitat use and how these regions are interconnected. It also just shows how these sharks use the inshore coastal regions to move between the various regions. Seasonal movements, so these latitude plots of 4 males, they just show the very clear north-south seasonal movements. That northward movement coincides with kind of autumn to early winter, and that's when these sharks are known to move up to the central KwaZulu-Natal coast for aggregation sites and mating. And then they return back in the summer months back to a similar latitude or region. And then we had 7 female sharks, also very clearly showing that north-south movement. You'll notice there's a few there that kind of showed very little movement for the first few years. This is likely due to them being juveniles or immature when they were released. And as they came up to maturity, then they started to follow these northward movements again as they became more mature. Just a quick recap of the results. So we had a large overlap in habitat use between males and females. There was no significant difference in that regional usage. Males tended to travel a little bit further north than females. Females were detected slightly further west. This latitude movement was very similar to that of wild sharks that have been tagged. What I did find, though, is the males tended to swim slightly faster on that southward return journey than females, and the females tended to cover slightly greater distances on that southward journey too. So where to from here? This really is just the tip of the iceberg. We still have 15 active tags out there. Our last tag is set to expire in 2036, so there's a lot more data to come in still and to process. We have very recently just extended the study to spotted gully sharks, so we have released 7 so far in the last 2 years, so it'll be exciting to see what they do and the data that they bring in. But the ultimate question from this study was, do these sharks that survive once they've been released back into the wild? And the short answer is yes. We've had a over 80% detection rate, and we've had 17 individuals with detections for more than 5 years post-release. So it clearly does show that these animals are able to integrate and adapt back into the wild after being in an aquarium environment. And with that, I'd like to thank my supervisors and these institutions for making this work possible and for being here today. And if you have any questions, please feel free to contact me or find me at the bar later at the gala dinner.
Thanks, Kevin. You did a great job on time. We actually have time for a couple of questions if people have them.
Damn.
Here's one. Kathy.
Oh, hello. Nice talk. I really like it. I want to know, how do you acquire these animals? When they are like really small, or how long they were in the aquarium?
So we collect both, well, it's not quite mature, so the larger sharks, we collect them between 80 and 100 kilograms, and then we collect the juveniles as well. The juveniles we don't collect anymore. The juveniles spent about a year on average in the aquarium, whereas the larger sharks were a bit longer, up to about 5 years on average.
Do you think that it's related because they're post-survival, because they were before in wildlife and now they are releasing it like memory-related something?
It definitely does. Yeah, it definitely does have an impact on that. So, I mean, they don't lose their survival instinct. We've seen it in the exhibits, the natural predation, that natural instinct to hunt. They don't lose that at all. So it definitely does, help.
Yep. Thanks. Okay. Kathy?
I just had a quick question about the data you presented for the tag re-sightings. Now, a lot of them ended up stopping a while ago because you only had ones that, there was not all of them that went up to 2025. Do you know what's happened to those other ones?
I don't.
Okay.
That's the downside of acoustic data, and that also shows that, I mean, we had some sharks that disappeared for 5 years before their first detection. So our acoustic array is very inshore, so if they are slightly further offshore, we do also have very dynamic seas along that side of the coast, which can just shorten that listening power of those receivers. So yeah, it's one of those. Absence of detection doesn't mean it's absence of presence.
Thanks, Kevin.
Thank
you. Next up, we have Dr. Christine Dudgeon, who's going to talk a bit about the genetic considerations of shark rewilding. Chris.
Hi, there was a little video there. I'm not sure what's happened. Yeah, thank you very much. So I'm with the STAR project, and I suppose I'll probably stand here. Is that better? And also with Biopixel Oceans Foundation and Uni of the Sunshine Coast in Queensland. This work is with a lot of collaborators, so I just want to acknowledge that. So genetics is really important to rewilding, and along with species and ecosystems, biodiversity is one of the 3 pillars of biodiversity. And so it is a big consideration in any rewilding project. For the STAR project, and for anyone who wasn't here before the break, this is rewilding of Indo-Pacific leopard sharks. It is part of our vision statement, which is re-establishing healthy, genetically diverse and self-sustaining populations. So this genetic diversity, the big question is, how do we go about doing that? And it's essentially a balancing act between these 2 somewhat opposing forces, so inbreeding depression and outbreeding depression, and which both can result in reducing the fitness of progeny and populations. So what we're really looking to do is maximize the sweet spot, where we get that maximum fitness. So outbreeding depression, I'll talk about just a bit quickly. This is also known as genetic pollution. The concerns here are if you bring animals that are too far distant from your target population, it can reduce fitness through a few different means. One, it might be that those animals themselves are not well adapted to that environment. They may swamp any local adaptations, which is more impactful into the future. Or they could also break up any sort of co-linked loci or genetic markers that are important to each other into the future. So potential for reducing fitness. But the question is, well, how distant is too distant? And this is not an easy thing to answer. Most of the work in rewilding has been done in terrestrial systems, and it's actually quite controversial as to where do you source your animals from. And in this particular case, we're talking about the practicalities of rewilding, not so much theoretical studies. So we do need to take into consideration things like, what is the species that you're working on? What's the ecology, biology, the distribution? What do you know about the place that you want to release them into? And what do you know about the breeding animals that are available to your study? So with the Indo-Pacific leopard sharks, we had some of that groundwork done already. So this is work that I had published back many moons ago using mitochondrial and nuclear microsatellite data. And so this, across the distribution, we found the major divide at a global scale was coinciding with this area through the central Indonesia, which is the Indonesian through-flow current. And it's also an important biogeographical barrier known as the Wallace Line. So for those of you not familiar with Alfred Wallace, he was a contemporary of Charles Darwin. And so while Darwin is over in the Galapagos coming up with a theory of natural selection, Wallace was doing the same thing here at the same time in Southeast Asia. And so for many centuries, we've known about these biogeographic breaks for terrestrial animals, but since around the 2000s, we've been finding more evidence of this in the marine environment as well. So what this means practically for the STAR project is that on either side of that line, we have what we basically call the western population and the eastern population, and those 2 yellow stars coincide with where we currently have our release projects in Indonesia and in Thailand. So we want to screen animals to see if they have the genetic signature of either of those major populations. Now, we have been iteratively continuing this work, so we keep adding new samples as we collect them. We've been looking at other markers, including SNPs, and just in general, that pattern still is holding, which is great. We don't know a lot about these more extreme parts of the distribution, so if I haven't spoken to you yet and you have information on that, I'd love to tap into that, please. So the other side is we need to talk about inbreeding depression, and this is a little bit more intuitive. If animals are closely related, that can cause problems with fitness. We're basically sharing too many genes from through descent rather than by chance. And generally, this sort of tends to have ongoing health impacts for the individual, but also the population. So part of our project is that we screen those. We have the microsatellite database as part of the husbandry program. So we'll screen every potential pair of breeders in aquariums around the world that are part of this. And just our cutoff is 1st and 2nd degree. So if it's full sibling, parent offspring, half sibling, grandparent, grandkid. When we start to get into cousins and lower relatives, it becomes quite difficult to distinguish those. One major consideration with inbreeding depression is this phenomenon of parthenogenesis. If you're not familiar with this, it literally translates to virgin birth, and this is where females can produce babies all by themselves. It's now been documented in at least 12 ray and shark species across diverse phylogenetic lineages, and so we don't know exactly how it occurs, but we do know what the DNA signal of it is, which is essentially the offspring has the same genetic diversity of the egg cell of the mother. So it's half of her genetic diversity. It's not a direct clone. And so when this was first being documented, it was really found mostly in females that were in tanks by themselves, didn't have any exposure to any males. So people are going, oh, how is it miraculously making babies? And started looking into this. But since then, we've done a lot of screening and finding that it occurs also when there are males present, even if mating behavior has been observed. So because parthenogenesis does reduce the fitness, that we do get elevated mortality in the parthenotes, we screen for that in the first batches of eggs of any new breeding pairs that are coming in to try and reduce the number that end up being sent and released. So to date, we've screened 177 animals across 49 institutions, and this is globally. So these animals, the leopard sharks, are found across the world in aquariums, and we have 12 approved breeding institutions with others onboarding. So to be an approved institution, it's not just the genetics, there's a lot of other onboarding elements as well. But as we start to sort of divvy it up into east and west and relatives, we've reduced our number of breeding pairs, and so we're trying to find different ways to increase the genetic diversity in our breeding populations as well as in the wild. So I'm going to finish by introducing you to our latest research project in Australia, known as the Great Australian Stegostoma Semen Expedition, or GASSI for short. Thank you, Nesha, for this one. And basically, this program is about, so Paolo Martelli from Hong Kong Ocean Park had developed a method for extracting semen from the male leopard sharks on scuba in the aquarium, and then testing that in artificial insemination. So we tried this out in the wild. So this is the wild, not an aquarium. So these animals are pretty compliant to being sort of grabbed and turned over. This one needed a little bit more encouragement to go into tonic. And then once we have them in tonic, basically the idea is to insert this tube into the genital papilla, which I also call the dangly bit between the claspers. So as you can see here, and it gets inserted into the sperm sac, and then the sperm extracted. And then we have taken that sperm and inseminated some females in our partner aquariums in Australia and also Singapore. So I don't have any results to present on that, but Siobhan, who's talking a little bit later, will talk a bit more about the sperm itself. And thank you.
Thanks very much, Chris. If anyone has a quick question, we can take one quick question for Chris. Overwhelmed with a great Australian Stegostoma semen expedition. Okay, we'll move on in that case. Thanks very much, Chris. And next up is Dr. Steve Kessel. There he is, who's going to talk about the role of spatial ecology research as a critical component in Elasmobranch reintroduction. Steve.
Thank you. Thank you all for coming. Huge thank you to the conference organizers. I'd just like to start by quickly acknowledging my co-authors, and while numerous, we are just representatives of the much broader ReShark community whose huge efforts have gone into these reintroduction programs. Conservation is a team sport, and if that statement is true, then ReShark is a huge testament to that statement. The future is now. We say that because, as you've seen from the other fantastic talks in the sessions, Elasmobranch reintroduction programs have started. But they didn't just happen overnight. There's a huge amount of effort and planning that has gone into them prior to ever releasing the first shark. And that's really important to make sure that these programs are both ethical and have a good chance of success. One of the key considerations in the planning phase is spatial ecology research. In the planning phase, it defines many different things about these suitable release sites when we're trying to identify them, both in terms of the ecosystem requirements, but also the spatial protective measures and the extent of those spatially protective measures that are essential to make sure that we're not just feeding the fishery with these sharks and that they have a good chance of establishing a population. When we're looking at post-release monitoring, spatial ecology is incredibly important to assess survival, dispersal, and population establishment and essentially success of the program. So I'm going to give you two examples, two case studies, one from the planning phase and one from the post-release monitoring phase. The case study from the planning phase is from Shark Ray 360. If you didn't see Riley's talk before lunch, Shark Ray 360 is a collective of people and organizations that are dedicated to the conservation and recovery of the critically endangered bow-mouthed guitarfish. As this collective came together and we started to assess the potential of reintroduction for this critically endangered species, one of the key data gaps from the wild population we identified was spatial ecology. If you look at this animal, you'd be forgiven for thinking that this is probably a benthically associated species and probably very coastally associated species. However, in 2001, this paper was published of an account of an individual miles offshore in the Indian Ocean, over thousands of meters of water, associated with a school of tuna. We were hopeful this guy was just a bit crazy, but apparently this is quite a persistent behavior within their life history, as this paper published in 2025 reported multiple accounts in a similar area in the pelagic fishery of bow-mouthed guitarfish. So we went about trying to study their spatial ecology in other parts throughout the species range. And I'm going to present three examples from our efforts today, which is not exhaustive, but one individual from Taiwan, one individual from Okinawa in Japan, and one individual from Northern Australia. All three of these were tagged with wildlife computer mini-pat tags, archival tags. The individual from Taiwan was a juvenile male. He was released off the Penghu Islands, which are to the west of Taiwan, the mainland of the larger Taiwan island. During a 70-day at liberty period, this individual moved 23 kilometers to the northeast. We were very fortunate because Nanjay and his team were able to go out and recover this tag, so we got incredibly detailed, high-resolution depth and temperature data. The black lines on the top of these charts are light levels, and the lower plots are depth profiles that are color-coded by temperature. And if we zoom in on the middle, two middle plots there, inside of these red boxes is during the night, and outside of them is during the daylight hours. And we see that a lot of the association with the surface and the very shallow water comes during night, with more use of the water column during the day. The individual tagged in Japan, in Okinawa, was a juvenile female. She was at liberty for 45 days, and she traveled 105 kilometers, so further than the individual in Taiwan. We were not able, despite our best efforts, to get this tag back, but we did get pretty good data back through the satellite transmissions. She had access to deeper water than the individual in Taiwan, and she used it. She went down in excess of 150 meters. And if we zoom in on this section, that's a good chunk of reliable data or pretty comprehensive data. If we consider this by dial activity, inside the gray boxes is nighttime, outside of them is daytime. We can see again surface association seems to be occurring during the night and more use of depth during the day. Finally, the individual tagged in Northern Australia at the end of last year. She was at liberty, she was a 225 centimeter female. She was at liberty for 134 days, and she moved a total of 40 kilometers. We got pretty good data again through the satellites. She did use a lot of the water column. She didn't have access to the same kind of depths as the individual in Japan. And again, zooming in on the section where we have pretty consistent data, we can see that looking at dial activity, it's very similar to that smaller individual from Okinawa in Japan. And this bear out in the time at depth plots. Most of the surface association was coming during the night. So what has this told us, and what do we still need to know? Well, this represents, to our knowledge, the first wild movement data for this critically endangered species. It's given us an idea about horizontal movements and their capabilities of horizontal movements at different time frames. It's also told us about their dial vertical behavior and their depth use. And all of these individuals are also acoustically tagged, and we're very hopeful we could get some good data from that, particularly from Australia, where they have that very large and well-coordinated acoustic array. What do we still need? Well, we need more animals. One of the problems with studying a critically endangered species in this manner is that they're very hard to come by. We've had some good success with partners, but we are looking for more partners. So if you think you could help us tag some bowmouth guitarfish, we have the resources and we have the tags, we just can't get the animals. So if you think you can help us do that, we would love to collaborate with you. Please send me an email or come find me at the banquet. If you do that, please do it earlier or I might not remember. The next case study is from Post-Release Monitor. Nesha presented a little bit of this data in a fantastic talk earlier. This is from the STAR project in Indonesia. At the time we put this slide together, 65 individuals had been released. All were internally acoustically tagged. And to track them, there were 2 arrays because there's 2 release sites, 2 hatcheries, one at Cree in the north and one at Miso in the south. The yellow stars represent the release locations and the red dots are the acoustic receivers. So looking at some of the movements across the entire MESOL array, this is all combined for some of those individuals released there. We can see that there's pretty good use of the array area and some potential hotspots within there. But if we look at this temporally, what we were finding is after release, after about a couple of weeks, or some of them 2 months, we've been referring to this to the exploration or discovery phase. A lot of them would seemingly leave the array and their fate was therefore unknown. It was therefore necessary to employ a different technique or an additional tracking technique. And luckily, wildlife computers developed the micropat tags, and we felt that these were just about small enough to deploy on these pretty small individuals. So multiple individuals have since been released at both release sites. Here we are showing for Cree, the red polygon is the extent of the acoustic array. The yellow star is the release locations, and then this describes the movements outside of the acoustic array area. So after that initial discovery phase, they are seemingly moving outside of the array area, and some of them making some pretty big movements, and that's particularly true in MESOL, where I'm showing the same thing here with the red polygon and the yellow star. One of these individuals is listed here as, in addition, in excess of 250 kilometers, but if you account for the landmass, as Nesha said in her talk, that's over 400 kilometers, which, while not as extensive as maybe Ryan Daly's bull shark, this is still a pretty significant movement for such a small animal. We think they may be moving out to the mangroves once they leave. So what has this told us so far? It's an ongoing process, but the combination of techniques, both acoustic and satellite telemetry, are giving us a better idea of dispersal, and this is also going to guide us in expanding that acoustic array to maybe cover some of these other areas and have longer-term tracking in terms of survival and establishment. The micropat data, in terms of the depth data, I didn't present any here, but what it did tell us was that these individuals, while they're moving, they're spending quite a bit of time at the surface. Thankfully, not microwave telemetry, they call me for saying that, wildlife computers, if you heard that, sorry. They have been producing very small locational tags, spot tags, that are designed for sea turtle hatchlings, and these recharge the battery using a solar panel. You can see them out there. We're not getting a commission, I promise. So Mark and Nesha were just in the Cree nursery, and right before they came to this conference, they deployed a couple of these as test beds on 2 individuals that are also acoustically tagged, and they're getting some really fantastic data. So this is another tool in our toolbox we can use to hopefully elucidate their movements. So a very quick overall summary. Spatial ecology research is a key component throughout the process of Elasmobranch reintroduction programs. It's essential to identify effective study sites and monitor post-release success, and also beyond this, for other species, particularly things like the bowmouth guitarfish, where previously we knew next to nothing about their spatial ecology, it has broader benefits to our understanding of their life history and potentially important for their conservation. I'd like to thank some, not all of our contributors and partners, and thank you very much.
Thanks very much, Steve. We're pretty much at the 10-minute mark, so people will find you later. And with that, I'd like to introduce Dr. Jaya Ratha, who's going to come up to speak a little bit about internal acoustic tagging. Jaya.
Thank you. Good afternoon, everyone. So I'm Jaya. I'm from Thrive Conservation, and I'm also part of the STAR project FED working group for Indonesia. So today, I'll be sharing our field experience with internal acoustic tagging in juvenile Indo-Pacific leopard shark within the context of rewilding effort. And we wanted to share, to understand the impact of the procedure by closely monitoring wound healing and behavioral response to better understand how invasive this method is in juvenile shark. So why does this matter? Successful rewilding depends not only on releasing the animals, but also to understand or to know whether they survive, where they move, and also how they adapt to the wild. So therefore, to answer this question, tagging provides essential data, but the method is inherently invasive. At the same time, there is still limited guidance on the application of internal acoustic tagging in juvenile shark. So this raises an important question. How invasive is internal tagging in juvenile shark, and is it suitable for the rewilding application? To answer this, we have 3 questions. First, how well the wound heal after surgery, and second, how sharks behave, whether they continue feeding and swimming normally, and the third, how well the tags perform, whether they are retained and suitable for juvenile shark in a rewilding effort. So as has been mentioned before by previous presenter, that this work is done in Raja Ampat, Indonesia. The activity is located in 2 nurseries. One is in Kri, up in north, and one is in Misol, in the south. So within this project, juvenile leopard shark are hatched and raised in semi-controlled condition before being released into the wild, which this condition provide a unique opportunity for us to observe recovery before release. From late 2022 till end of March 2026, there are 74 juvenile of leopard shark has been tagged. The tag size was matched to body size, with the majority of shark measuring approximately 90 to 100 centimeters total length, fit with V16 tags. Tags were surgically implanted through a small abdominal incision of approximately 3 to 4 centimeters, and then closed using non-absorbable sutures. Following the procedure, sharks were closely monitored during 10 to 14 days recovery period. As you can see in this image, we utilize underwater photography to maintain a daily record of the wound site. This allows us to track the healing progress without needing to handle the animal repeatedly. So what did we actually see? So within approximately 4 weeks, the wounds were generally fully closed with minimal visible scarring, like shown in this picture. In terms of post-surgical behavior, we noted a short-term reduction in appetite. Typically, this lasted just several days, and in some cases up to 1 week. However, feeding behavior subsequently returned to normal and swimming behavior remained stable throughout the recovery. We also observe high tag retention with only 3 expulsions. In each case, the tag was found outside the body following wound closure and suture removal. While investigation in the mechanism are ongoing, we suspect expulsion occurred through the colymic spores located around the cloacal area. And the post-surgical survival was 94.6%. Mortalities occur after the healing phase and suture removal, with multiple potential contributing factors involved and no direct link to tagging procedure. This, I would like to show you some images illustrate the progression of wound healing and post-surgical recovery over time. This is Kathleen. So Kathleen was one of the first shark that we tagged on the first batch in December 2022. So as you can see, the progression of the healing and after 12 days, we then removed the suture. Same thing, this is also Charlie, was tagged in late 2022. It shows a recovery, and even like we removed the suture after 10 days of the surgery. Same thing with Lisa, that was tagged in 2025. It was even like we put more stitch to Lisa, but after 12 days, we also, the recovery, so also a good healing from the surgery. So beyond the result, there are also some practical lessons we have from the field. First, post-surgical monitoring is critical in determining recovery success. Second, tag size must be matched to each shark body size and condition to minimize the tag burden and reduce impact on behavior and recovery, while considering specific species morphology and body cavity volume. And third, giving enough healing time before release is essential. From our experience, success depends not only on the surgical procedure itself, but equally on how recovery is managed afterward. So what does this tell us? This result suggests that internal tagging is well tolerated in juvenile shark and can be effectively applied when supported by appropriate surgical protocols, recovery condition, and monitoring. So this makes it a viable approach for rewilding application. It is also important to note that these findings are based on a monitoring of period of around 1 month before release. Therefore, long-term effects still need to be evaluated through continued post-release monitoring. And nevertheless, since this is an ongoing project, this information provides an important baseline for future work. And ultimately, rewilding can only succeed if animals survive, and ensuring survival requires the animal welfare and monitoring to go hand in hand. So I would like to sincerely thank the STAR project team, especially the veterinary working group, as well as the aquarists. There's Mardia here, and also all of the interns. There's Kinan here also, who's previously one of our interns, and who took care of the shark wholeheartedly. We also would like to thank all supporters and the Research Global Coalition for making this work possible. Thank you.
Thanks very much, Jaya. We're going to have to move on. If anyone needs a question for Jaya, you can find him afterwards. Next is Dr. Hugo Lassauce with the saucy title of Loyal Mothers and Multiple Fathers. Let's hear about it.
So good afternoon, everyone. I would like to tell you a little bit of a story about reproductive behavior on these leopard sharks. So I'm not going to go into many details about the species biology, but one thing we need to tell here is that they're actually laying eggs, and the eggs are laid in clutches, and they are found attached to a structure on the substrate. And then the embryo develops, and after several months, they hatch. But we actually never see the mother doing the act of laying the eggs, and we don't know if she returns. I don't know what shark is the father. And this is a big challenge to make the reproductive behavior in the species and try to understand it. So within this whole session, we've been talking about research program and its goals, but what I want to emphasize here is where our study sits in the program and the pipeline of the program. Before we make any decision about captive breeding ratio, timing, and protocols, we need wild population reproductive baseline, and this is still lacking. So this is where our study sits, and the outputs and the findings in the study will then help the program to be a success. So we try to understand three main questions in this study. The first one is very basic: when and where the eggs are laid. And the second one we asked is how many females are contributing to one given egg-laying site, and do they return to the site across several years? And finally, we asked, in case of a single mother laying the eggs, how many fathers are there? So let me take you through this. But first, the story begins in New Caledonia, at one of the most popular beaches of the capital city, Nouméa, that is called Limon Bay. In 2013, there is a group of citizen science enthusiasts, snorkelers, that are known as the fantastic grandmothers. And they began to report the presence of leopard sharks' eggs in the bay. And so the scientists of the aquarium, the lagoon, started to collect the eggs and recorded the exact position and abundance. So what began as a conservation initiative became decade-long daily monitoring data sets, which is very hard to find such temporal resolution in Elasmobranch research. Then from 2023, we were able to expand our monitoring to a second site called the St. Mary Bay, not very far from the Limon Bay. And also through the collaboration with Cairns Marines in North Queensland, Australia, we were able to include a third site where the eggs were collected in 2023 and 2024. So the question, where are the eggs, when are the eggs laid? So the entire monitoring period, both sites in New Caledonia, every single eggs were deposited between October and January, with the peak in numbers consistently being in November. The estimated season here in red in the graph seems to coincide with the rising phase of the temperature, the sea surface temperature, and the longest day in the year. I would like to highlight here that the end of this season is right before the temperature reaches their maximum. And the maximum is actually when the eggs will start hatching. So in Australia, we found similar results with the eggs observed and collected in November and December. Where did we find those eggs? So first we collected 18 eggs in average per season in Limon Bay only. And it was easy to find them because they were really close to the shore, like less than 50 meters away from the shoreline, at really shallow water from 2 to 5 meters maximum. And all the sites were really gathered within a 200 meters area. It's also important to note that these positions were consistently the same across the 10 years of monitoring. The eggs were found on isolated structure on the flat surface, sandy, with like rocks, coral rumbles, corals, sponges, everything that is a little bit standing alone with some space around, so maybe the female can just navigate around it. Again, this consistency in the same position on the bay, roughly the same number of eggs per year, we got us thinking that it might be only one female laying the egg, at this site. So to confirm that, we used genetics. We used the kinship analysis. So it works that we calculated the relatedness between every pair of individual, and the principle is straightforward. There's two scenarios. If all the siblings are full of half siblings, then there is only one mother at the site. If there is unrelated siblings or unrelated individuals or third-degree related siblings, it means that there is multiple female at the site. So the question now is, how many mother? One or more? And this is the results. So this is a complicated figures, but it's just showing each cell in this map is a pair of individuals and the relatedness between them. So if it's red, it's for full siblings. If it's orange, it's half siblings. Yellow is for third-degree related, and white is unrelated. If we look at the green square here, it's Limon Bay, and all the siblings are either full of half siblings. So it shows us that it's only one mother at the site, and this is across several years too. For the St. Mary Bay, it's the same pattern, only full and half siblings. So again, a single mother using this site. But when we look at Australia, there is definitely a different scenario where we have unrelated and mostly third-degree related individuals. So, well, we've been doing other analysis that I'm not going to present, but it confirms these results too. So knowing that all offsprings at each of the sites in New Caledonia came from a single mother, we then ask ourselves, how many fathers? And the picture is a little bit complex here. We got the figures that, so bear with me. There's every square is an egg. Every pile square are a clutch. And the colors are representing fathers. And the white one are fathers that have been detected only once. So the take-home message on this figure is that we found that within a single clutch, there is different colors, so different fathers. So there is multiple paternity within a single clutch. And also, there is some colors, like the green one here, that is being observed across years. So this suggests repeated paternal contribution across breeding seasons. So despite the strong female philopatry, the reproductive system itself encourages genetic diversity. It also shows that a male returns to the same matings area year after year, and could also be that the female has a way to store the sperm across several seasons. So what does that deliver to the ReShark program and the conservation of the species broadly? We now have a mating benchmark that multiple fathers can mate and fertilize a single female with the potential of inter-annual paternal overlap, or captive breeding programs and protocols needs to target this level of paternal diversity. We also have the Limon Bay as an ISRA, thanks to the data generated from this study. And there's also reproductive timing. For ReShark, timing may be critical for artificial insemination success, as the fertilization of the female may be more favorable at certain period of the year. So understanding the hormonal mechanism underlying these reproductive events will be the next step to take. And finally, we have also habitat characterization. So by describing the sites where the legs were found, we can have a search image that we need to look at more sites. And it can be a matter for both reintroduction, site selection, and for conservation more broadly, like those sites can be very fundamental microhabitat for the species recovery. I would like to thank every partners and give a special shout out to Mark Edman and Christine Dudgeon that are here, and thank you for the support, guys.
Thank you very much, Hugo. We do have time for a quick question, if anyone has a quick question for Hugo. righty. In that case, we'll move on to Siobhan. Siobhan, you're last in line. Definitely not least.
Hi everyone, thank you so much for sticking around for the last talk in the last session of the conference today. I really appreciate everyone coming to listen to me talk about my PhD research, which is in partnership with ReShark and specifically the STAR project. The first step, or one of the many important steps towards a successful rewilding program, is to understand the reproductive biology of the focal species. By building on this knowledge, we can inform the development of assisted reproductive techniques and strengthen the future for rewilding efforts, not only for this species, but hopefully we can develop models for other species as well. So my focus is on reproductive endocrinology for both sexes. I am going to be looking at both in situ and ex situ sharks, and the aquarium sharks are housed in near natural conditions. Ooh. As we begin to utilize assisted reproductive technologies in rewilding efforts, it is becoming clear that, as Hugo's just mentioned, success ultimately depends on understanding reproductive timing. So my research aims to focus on the male side of this timing. Previous work in the USA on sand tigers determined that there's a strong link between seasonal peaks in testosterone and semen quality. We want to examine if this holds true for the Indo-Pacific leopard shark. This study also highlighted the importance of using in situ and ex situ populations. So how do we go about this? So fortunately for me, Chris has already delved a little bit into how we go about collecting the semen in that very intimate video that she showed before. But before we collect the semen, or I should say in conjunction, we're also taking blood, and that's in order to analyze the blood plasma hormones, and we're taking morphological measurements as well. So once the semen is collected, it is very fragile once it's outside of the shark's body. So it is placed into a vial with an extender and then chilled while we transport it back to the lab. As we look to transfer gametes between in situ sharks and ex situ populations, and even as we look to transfer these between institutions, it's really important that we consider the presence of pathogens. So part of my research is also doing some microbial testing. So in essence, I'm looking at shark STDs. And then we go into the lab. So once we're in the lab, we start to assess our semen, and it's assessed in a variety of different ways. So we're looking at the volume, we're looking at the viability, the motility, and the concentration of the semen. It is then given a score, 1 being most optimal, 2 is where we have one parameter that is missing or is subpar, and then 3 is it's not viable, and then we discard it. So obviously we're still assessing it, it's still making up part of my data, but this is really important for the artificial insemination attempts. So far we've had 2 field seasons. In 2024, it was basically a bit of a pilot study to get the process working, test the methodologies, including the underwater semen extraction. We were able to sample 22 males, and then in 2025, we hit the ground running and we sampled 42 males. It's good to note that we have also sampled similar numbers of females during both seasons as well. These 2 trips did focus on 1 month of the season, and this is preliminary work to test the relationship with the idea to do this across an entire aggregation period. The data here is preliminary, but you can see comparatively the semen quality analysis between the 2 sampling periods. Sperm counts were highest and most variable in 2025, with several individuals showing extreme peak values, which suggested active or peak spermatogenesis. What I will note, though, is one of those really high values is extremely high value of semen concentration, but over half of that semen was actually dead. So high concentration does not necessarily transfer to high quality semen. In contrast, in 2024, we showed a more moderate and consistent sperm production across all individuals. And then our aquarium animals had consistently lower and less variable sperm counts, indicating suppressed or non-peak reproductive output. However, we really do need to consider our aquarium sharks. They do have access to opportunities for continual mating, and we are sampling quite often after these periods have occurred. So we do, something that we are going to factor in is regeneration after mating. But that is also consistent with the study that was conducted in the USA as well. The aquarium house sharks generally have lower quality semen. Oh, that way. So next steps, if you're looking for me over the next couple of weeks, I'm actually going to be in the lab, head down, starting to analyze these hormones. We are just organising our next gassy trip, which is set to be bigger and better with more semen. And then we're also going to continue our sampling of our aquarium house sharks across the year. So I haven't got a thank you slide, but I do want to thank everybody that's involved in not just my project, but in all of the rewilding efforts that's taking place across the world. Successful rewilding is a massive collaborative effort, and thank you to everyone involved.
Thank you very much, Siobhan. We're towards the end here, but we definitely have time for a question or two. Kathy, hand up quick.
I want to know if you found any STDs.
No, not yet. So the idea is, part of my project, we want to look at whether we even need to use semen, antibiotics in semen extenders, so that'll be the next step. But right now, no shark STDs, which is great because we've already inseminated quite a few aquarium house sharks. So.
Can I ask you a question as well?
Yeah.
Yeah, so being a male and I also have a dangly bit, seeing that movie was a little bit disturbing.
Yeah.
Did it have an influence on their future performance?
As in, did the dangly bit have an influence?
No, the sampling. Did it?
The sampling have an influence on
their future performance?
Oh, unsure. So this is something that we're trying to find out. So obviously we're sampling, we're taking the semen. We're not sure how long it takes to regenerate.
Okay. Any final questions, or are we all good? Alrighty, well, thank you everyone for coming to the Elasmobranch reintroduction section, and enjoy your break. Remember, there is a final plenary session that starts